All right, we're picking up the Starliner coverage here. Welcome. Hello, and welcome. Picking up the Starliner coverage here. They were showing the telemetry, so I'm like, yeah, we gotta put that up. They were showing the telemetry again. So welcome to Starliner coverage here. Blap! Please show camera. I love docking view from the ISS. I'm pretty sure we'll get something like that soon. Starliner is still a little ways off from the ISS. It's a little bit below and behind it right now. It's before we're pre-coelliptic burn. If I'm looking at those charts, I'm actually, for what it's worth, I'm actually reading the. You can just read the telemetry. They just straight up don't care. They just put the telemetry right up on there, which is actually pretty sweet. It's a little ways out from the ISS, and it's not circularized out in front of it yet. That's going to happen in a little bit.
Discovery, go at throttle up.
Yeah, let's pick up the coverage and go from there. So this is the Starliner docking coverage. This is a small part or a major mission milestone of a much larger mission called the Orbital Flight Test 2 mission, which is Boeing's test to make sure that their capsule can get up to the ISS and safely get back down. This is a test flight. It's a follow-up test flight because the Flight Test 1 was not up to adequate standards for moving people, to say the least. There were some software problems and then some processing flow problems leading to corroded valves on the service module post-flight that kind of has delayed Starliner a little bit, but hey, this thing's up, she's flying, everything is working really good from what I understand. They did have some sensor problems, and those sensor problems led to some engines not working exactly how they intended. The behavior is well understood though from all the information I can gather. So we should see them pick up the docking operations here in a little bit. Docking is scheduled about 2.5 hours, 2 hour 45 from right now. Hey, Perky, 48 months, the nap van with a 6 month. Thanks, guys. They messed it up. Guys, the software one was a big foobar. That was not good. This time around, having a little bit of a weird sensor reading causing engines to automatically shut down by the flight control computer, that's no problem. Don't get me wrong, it's behavior that needs to be understood. You need to figure out why it's happening, and you need to prove that it was a sensor that shut the engines off. However, as long as you understand why that behavior happened, it's fine. It's okay. You're still clear to go with the mission. This is why Starliner has 12 OMAC thrusters. Now, flight controllers at Boeing and NASA have been working that problem, and from what I can understand, they think it's a sensor. Now, don't get me wrong. The information about Starliner has been a little... So, I'm not sure. I might be connecting too many dots on that one. But it seems like bad sensors were the problem. Now, once again, this happens. It's a test flight, guys. Remember that. You want to find problems now. It's interesting, right? Because test flights are like final exams, right? They're like a final exam for school. You ideally don't want to learn anything new during a final exam, ideally, but you absolutely have to get as close to 100 as possible. Hey. So, if you don't pass the final exam, because criteria for passing is very, very hard to achieve. If you don't pass the final exam, the next time around you'll learn another way to do it. You'll be better at it. With spaceflight, you can fail the final exam. It's happened before. It happened with Starliner. That's normal behavior. But the whole purpose of these tests is, it ends up kind of being a beta test. Just how a beta is a final test for software before it goes into release, right? Same idea. Finding problems is not ideal, but it's also not the worst thing. These are problems that you wouldn't want to happen when people are on board this capsule. So it has taken a little bit to get to this point, but we're here. So let's watch this thing dock. So this is yesterday. This is the replay from yesterday.
And again, looking back.
That's
That's
right,
a
Bobby.
camera aboard the Atlas V rocket, looking back at the solid fuel boosters, helping out.
Gotta find those bugs, dude.
That launch was timed just like these rendezvous and docking procedures are timed very carefully. That launch was timed to coincide with the time frame that the International Space Station was.
You mentioned yesterday that Atlas is going to retire soon. Does that mean Starliner will use another launcher in the future? Okay, so the commercial crew contract for Starliner is for 6 missions to the ISS. Those 6 missions were purchased on a firm fixed price, meaning the Atlas V's are already bought. They already have Tori Bruno has 6 Atlas V's waiting in the wings for Starliner. Now, because the 6 missions are contracted on Atlas V's out to, I don't know, ISS retirement, I would assume, because they're contracted that far out, dude, I'm not exactly sure. It really depends if NASA decides to want to buy more Starliner flights. There might not be the ISS might not be there by now, but with that being said, we know that Boeing has stated multiple times that they are long-term committed to Starliner's development because they're anticipating having one of the only rides to get up to a bolstering commercial low Earth orbit economy. That's why they're committed to it, because they think that they think the business is there to fly Starliner in the future. Now, with that being said, if they do that, they're going to need to find a rocket to put it on. I would imagine this, and now this part is the speculative part. I would imagine they'll probably use Vulcan. If I had to throw my hat into the ring, I'd imagine they'd stick with ULA. Spaceflight is all about going with what you know, right? So I can't see a scenario where we don't at least have the potential of Starliner to fly on Vulcan in the future. I mean, that's what makes the most sense, considering it uses the same exact pad. It's almost the same exact height. Starliner will literally be in the same spot, right? So the crew access arm will work. I can't see a scenario where that doesn't happen. However, it's important to say that that's speculation. That's just me putting in my 2 cents. There's been no contracts out for Starliner past the 6 Atlas V operational missions. So that's PCM 1, 2, 3, 4, 5, 6. So, don't know for sure. We did see a Starliner dock to orbital reef in one of the renders. Yes, that's correct. So it's very clear to me, Jax. Hey, ISS cam. What is very clear to me, dude, is that Starliner has a future beyond just shuttling people to the ISS. Boeing has at least predicted a future beyond that. They're anticipating an economy. And what I think it's wise to say that if they're if they want to go through with Starliner, they want to go through with it even after paying $400 million for this OFT-2 mission out of pocket and fixing all these issues. They still want to go through with Starliner, meaning that they still see profitability somewhere. They would pull out if they didn't see profitability, right? Sounds like something a huge corporation would do. They clearly see profitability here in the long run, and they clearly see a low Earth orbit economy in the future that has people living and working in space. And we've seen that with Orbital Reef, etc., etc. So you know that if they have long-term plans for Starliner and they're committed to Starliner, but that's probably they just don't have the contracts for these missions yet, but they probably have kind of sent out a couple of feelers like, hey, for your space station, do you want to use Starliner? And I'm sure people have said yes, like YIF or something. Could they launch it on New Glenn? It's possible, sure. New Glenn's a little bit overkill for Starliner, but yeah, sure, of course you could. Why not? Hey, Lithuanian, what's going on, buddy? Did they mention why they got a lofted trajectory? No. Oh, no. When Doc Oba, we're looking at about 7 o'clock. Did they mention why they got a lofted trajectory? No, they didn't do that, oh no, and that's probably because they probably haven't told us because they don't know the answer to that. Figuring out why the booster overperformed is figuring out why the booster overperformed is probably that's gonna take a little bit of data assessment to figure that one out. Yeah, it's gonna take a little bit. So here, let me. I'm gonna hush up for a second. Let's see where we're at.
Itself, rather than being installed on an ISS port.
That's correct, Jackson.
As cargo craft are handled. And he spoke with us recently about some of that effort going into the Starliner program.
The difference between berthing and docking is when you're berthing, and this is what cargo vehicles do, you fly up close to the space station.
Wait, what?
And then the flight crew's on.
Hold on, let me just back up.
One of the robotic arms and bring you in.
Can you tell Propa Grandpa how to activate in KSP when you can see the dynamic pressure? You got to open up Kerbal's debug menu. I have my debug menu bound to Alt F12 to open that window up. Alt F12 opens up the debug menu, and then you go to the arrow tab on the debug menu, and you open it up, you expand it, and then you go to the arrow menu, and then it says Show Arrow UI.
And then the arms and legs are the things that move you around. So we have the flight computers are the brain, and the guidance instruments know where they are. And so as you move through space, they keep track of that. And then there's a series of little jets.
No problem. All you got to do is ask.
So the eyes look, the brain thinks about it, and just uses the jets to move where she's supposed to be. So what we're going to do is fly in through a corridor. Imagine a pipe you got to fly through that isn't really there. So the spaceship has to keep herself inside that pipe, not come in too fast, stop, get clearance, and then connect with just the right force to latch everything in. So this is not something we can take lightly. We are used to those spectacular flight crews. All our machines are made typically, as is Starliner, where if the computers aren't going quite right, that flight crew can grab it and fly it. We don't want to have to rely on the crew. Not that we don't trust them. We'd like this to be a lifeboat too. Hope it never happens, but maybe someday she's got to take somebody home without help. And so it's not for the faint of heart to get this exactly right. Starliner isn't a shuttle replacement. Starliner is a piece of something much bigger than just the shuttle program was. And if you look at what our space agency is doing now, it's never been more interesting or fun.
4 is what NASA's contract states, Hip, but I think it could move more. But I think 4 is really the rule of thumb there.
And that's a look at some of the inside, some of the thinking that and the work that went into Starliner. Of course, Jim Chilton there representing the whole Starliner team. Nobody does this kind of thing by themselves. It takes a lot of work by a lot of people.
I wonder what he meant when he said Starliner is just one small piece.
We talk a lot about the
Starliner is just one small piece. Interesting. See what I mean? Boeing very clearly, they've cryptically said it a couple of times, Jackson. Do you hear that? They've cryptically said that Starliner is, they plan on using Starliner. They're committed to the project for a long time. But that's the first time that I've heard anybody from Boeing ever say that Starliner is one component to a much bigger architecture. That's very interesting. Pretty cool. Dude, I hope they got something cooked up real good, man. Gateway shuttling contract? It's possible. I'm not sure if if Starliner is really good to do what Orion can do. I think Orion is more of an Apollo capsule, and Starliner is more of like a really, really nice Gemini craft. Not in terms of architecture, in terms of capability. Meaning that the Gemini craft is really designed to go to low Earth orbit, and that's about it. Dragon is pretty much designed to do just that. If you wanted to go further with these capsules, amongst other things, you'd need a service propulsion system like that big honking one that was on the back of the Apollo service module. Yeah, I don't know. It's very cool that they're saying that kind of stuff. I'm looking forward to it. It should be fun.
Engineering from the University of Michigan, and is a frequent lecturer for many human spaceflight operations classes at Texas A&M. And outside of this, he has more than 8,900 hours on console in mission control.
I suppose you could do that, Bobby.
6,000 of which have been as a flight director. Is also co-authored.
If the capsule is attached to and riding, in the cargo bay of a much bigger vessel, then yeah, sure, of course you could do that. You'd have to find a way to get your vessel to interface with the larger spacecraft. That's what Orion can do. Orion is designed to do that from the start. I'm not necessarily sure if Starliner is supposed to do that. a lot of people don't know that, and I don't know why NASA won't talk about it. But I've read plenty of documents, and I've seen plenty of interviews saying that Orion is designed to interface with the spacecraft that it docks to. Not in the same way that like a capsule would dock to the space station. When the capsule docks to the space station, it's kind of just sitting there, and they plug it in for power, and they shut its life support systems off, and it uses the ISS's life support. It's basically like just like a dock. What Orion is designed to do is much more like Orion can attach to a ship, and it's specifically designed to be able to interface with a much larger ship, more than just power and life support. We're talking Orion can control the entire ship. You can control the whole thing in a very similar way to how the Apollo capsule could control where the LEM was going. They interfaced with each other. Not everything, though. They did redundant environmental control systems, and that one proved to get a little nasty, but it's okay. Apollo 13, I'm looking at you. Non-standardized fittings, am I right? So the Apollo capsule could go and pluck the LEM off, and then they would work as one vehicle. Orion can do that too, but it's not just designed to work with the lander. It's designed to work with a much larger vehicle, a transfer vehicle to Mars, if you will. That's what it's supposed to do. I don't know why they won't tell people this, but Orion can basically attach to a larger spacecraft and become the bridge of that spacecraft. Like, think saucer section from Star Trek. That. Like, you have a drive section, and then you have Orion, and it attaches to it, and it can control the drive section. That is not something that's easy to do in real life. It's not like Kerbal, where you're just like, oh, I'm attached to it. It's all one vehicle now. Designing multiple vehicles to interface with each other on orbit and interact with each other and allow one to be controlled by the other is something that is very difficult to get done right. That's hard to do. And Orion can do that. That's part of the reason why it's so expensive.
Ultimately a docking in front of the International Space Station.
Only the gateway right now, unless it had a transfer module attached to it.
Neil Bagata is taking the Capcom station now. He's flanked by
NASA's
Coach Will Moore, who, of course, is training to eventually fly aboard the Starliner spacecraft. Multiple Starliner veterans here. Coach Will Moore here in the Starliner flight control room. And then, of course, down the hall in the International Space Station flight control room, we've mentioned Sunita Williams sitting right next to the Capcom there.
Oh, he's got cracker
about
jacks,
10 seconds from the go no go for terminal phase initiation. This is where Ed Van Cise will poll the teams here in the Starliner flight control room, and we'll just stand by for the go no go.
That's the keep out sphere right there. This is the ISS's airspace, so to speak. They want to get right in, and they want to stop right in the approach corridor right there. See that? If you look, I think the blue. No. I think these are the deviations. They basically have to get all this to line up. You basically want to park it right here, right where my mouse cursor is. Think about this approach corridor, the approach corridor, and then there's the approach ellipsoid. And then the keep out sphere.
Officer reporting that the Starliner authority to proceed has been enabled for the approach ellipsoid entry.
See, that's this outer circle.
We call it ATP. It's basically a computer keystroke. It is what it's the command that the rendezvous officer sends up to the spacecraft, and it tells the spacecraft that it's okay to perform the next maneuver and position itself for the next burn that is coming up. As we mentioned, that's going to be the TPI,
that's the V-bar.
The terminal phase initiation burn. That's going to be coming up in 3 minutes and 40 seconds.
So, okay, 3 minutes, 40 seconds. So what's going to happen here, that is the V-bar approach corridor, meaning think of this like the runway, okay? Starliner has to align itself with the runway. You want to get these dotted lines right here. See how there's a difference? That's what they're going to make up. When Starliner burns here in a moment, the dotted line should go right into this rectangle right there. That basically is Starliner getting lined up with the runway. Think about a plane landing. Now, this outer one is the approach ellipsoid, okay? That's the approach ellipsoid. That's the ISS's airspace. The ISS has an ATC, just like an airport. It's a space station. It has traffic control. The traffic control is Houston, the ISS Mission Control Center. Now, you have to have permission to enter the approach ellipsoid, and once you enter the approach ellipsoid, they align you for whatever docking port you're trying to get to. In this case, because they're going to the very front of the space station, they're going to not Node 2, they're going to PMA 2 at the very front of the station. They have an approach corridor for Starliner that is lined up with the station's V-bar. So that's basically the really, really easy way to say that is they're lining up in the velocity axis of the space station. So the way it's going, they're going to get Starliner out and in front into the approach ellipsoid, lined up with the approach corridor right there. And then they're going to bring Starliner in. There's the burn. Watch, these numbers will go right into the rectangle here. Oh, no, that was just a correction. We have 150 until the burn here. It's a 0.68 meters a second burn. Very, very small puff of the thrusters here. So once you get inside of the approach corridor in the approach ellipsoid, it's like a plane coming in to land. Now, think of this, the keep out sphere. That's what this is right here. That's what that little circle is. The keep out sphere, that's like the airspace that's directly over an airport proper. You don't go there unless you absolutely have clearance to go in there. It works pretty much like a plane landing on a runway. Hey, tower, we're trying to land. Like that. I know it's pilots. I know that's not how it works. It would be like Charlie Sierra Tango 100 requesting permission to dock V-bar heading. Well, you'd have to head relative to the station, right? Heading, it would technically be 180 because they're coming from the front of the station going back, so it'd be south, I guess. And Banana, D died. Yep. Right. So, I mean, but this basically all works like air traffic control. It's similar. It's not exactly the same because space and not air, and there's no runway. It's just an imaginary approach corridor. You don't need a runway to land a capsule on the ground or up here. But, you know, they're going to do that burn here in about 30 seconds, and that'll get them basically lined up with the runway.
Away from the initiation of that burn.
So this right here says what they need to do on 3 axes of movement to get into the right spot. It's mostly forward and back, some up and down, some left to right. So you should see primarily the back thrusters fire with the side thrusters just a little bit. Here we go. Back thrusters. And then there should be a little bit of side thruster action, and then you're done.
Confirmation from the teams here. We are burning.
The Vigo is reading 0 at T plus 10. That was a nominal
burn. The burn has stopped.
They put it outside.
Confirmation to the flight director here. We have a good terminal phase initiation burn.
Okay.
We're heading inside the vicinity of the International Space Station.
Sure, W. How do you get live telemetry like this? This is just Boeing stream, dude. You want me to link you?
Burn, but that we have some time.
Houston, space to ground 2 for Starliner.
All right. Which one did we just do?
Station.
Starliner has completed the TPI burn. Expect to begin the far field monitoring task shortly. In step 1 of 1.103 CST 100 far field monitoring, expect a start time of 20:42.
Okay.
20:42 start time and copy all.
So I think that was this burn. I think that was maybe it was number 1. Yeah, they did say step 1, so that was the plane change.
So inbound fly around 1, that next burn that's coming up. Like I said, we have a little bit of time before that starts. That's a little bit more than 45 minutes from now. That does not mean that the crew on the ISS gets a break, or the flight controllers here who are watching the spacecraft carefully. But we heard a little bit from the crew there.
If he said TPI, that means terminal phase initiation plus burn and approach ellipsoid entry. So that means we're up here. We're on 4, not 1. Yeah, if he said TPI, I heard TPI as well. So if that was the TPI burn, yeah, okay. So I was confused by the telemetry that was there before, the one with the red and blue dotted lines, because the projected trajectory went outside of approach ellipsoid. I'm not sure if that's on purpose or not. We'll see.
Now, to address the space to grounds, you heard it's Bob Hines on board the International Space Station. Rob Hayhurst is the Capcom and the International Space Station Flight Control Room. It'll be him from the ground that's talking to the crew aboard. The Capcom's here, really just learning the procedures. No one on board Starliner today, but of course the crew has some duties ahead of them. Far field monitoring. You heard coming up here. They'll be using their monitoring tool called the RPOP. It's Rendezvous Proximity Operations Panel. It's a standard panel that the space station astronauts use to monitor any visiting vehicles that are approaching the International Space Station. Starliner, of course, being one of them, but they can monitor the cargo vehicles, the Dragon vehicles, all of the different visiting vehicles that approach the International Space Station. Of course, aside from their far-field monitoring tasks, just making sure that they have the visuals and they have a good connection through the Common Communications tool that provides a link between the two spacecraft. The system itself is called the C2V2 Common Communications for visiting vehicles. They'll just continue to verify the far field monitoring, and then of course we've mentioned a couple of the demonstrations that we'll perform once the Starliner itself is right in front of the International Space Station. We still have some time until we get to that moment, that inbound fly around burn. That's the next burn that will swing the Starliner in front of the International Space Station. There's 2 inbound fly around maneuvers to help us to do that. But that's not coming up for another about 42 minutes.
Okay. Yeah, they still got another burn to do, guys. So if that was TPI, they still got one more. So that would have been burn 4, if I'm thinking about it right. But next time the ground
we wait
comes
for
on.
for the next inbound fly around maneuver, or for the first inbound fly around maneuver. Since we have a little bit of time, let's take a little bit of a closer look at the full docking profile that Starliner is going to fly today. Again, it is flying itself autonomously. It accepts inputs, of course, from the flight control team, but no astronauts on board while the ISS crew watches.
Docking.
And so here's a little bit of what that's going to look like.
All right, let's see what we got here. Purple 2 looks really good, right? Okay, we're not at TPI. That's not where we are. They got to do the first flyby first. This actually helped. They're going to use the RCS. Yep. The audio's terrible, dudes. Terrible. Did anybody listen to this video before, you know, we published it, or? There's your keep out sphere. And then there's the approach corridor, the green. 2.5 hours, please. Hey, Sam Carr. Everything's good, man. I mean, you guys hear that. You guys hear the voice kind of talks like this, right? Like, that's like, yeah. That approach is actually pretty damn similar to Dragon's, guys. It's almost like NASA wants them both to do the same thing, or how two different planes would land exactly the same on a runway. It's very, very similar. The rendezvous, the RPod.
That's a good assessment, Joe. You can close and reopen the app, and it should work.
The rendezvous proximity operations and docking, or RPOD, RPod, it's pretty much the same. It's pretty much the same thing. So we should see Starliner come close to the ISS and then go far away, and then it should come back and then come in for docking. What they're doing there, fellas, is using differential eccentricity to do flybys around the space station. So if you picture the ISS's orbit in a circle, like the ISS is a perfectly circular orbit, or at least it has really low eccentricity, which means it's very close to being circularized, right? What they're doing here is intentionally putting Starliner into a slightly egg-shaped orbit. They use the difference in the shape of the orbit, or differential orbital eccentricity here, to make the capsule go up in front of this, like up near the space station, and then go away, and then come up near the space station again and go away. The idea is that it looks like Starliner is kind of flying close, doing a flyby, going away, and then flying back. But NASA does this to basically, visually inspect the vehicle, amongst other things, and this is a pretty dang efficient way of doing it. This is a pretty dang efficient way of like inspecting the vehicle for minimal amounts of delta V. Because they basically get to see the vehicle from all sides, because it's like flying around the space station. Once again, Starliner is putting itself into a slightly egg-shaped orbit. Okay, the ISS's orbit is pretty damn circular. The difference in the shape of the orbit, right, means that Starliner is basically going to look like it's coming up to the station and then going away, because it's in an egg-shaped orbit comparative. The first orbit that they're going to do is going to get Starliner close. I don't know exactly why they're doing that, but my guess is to visually inspect the spacecraft. They're probably going to look at it. That really, really is kind of a big deal. Every time the space shuttle came to the ISS post-2003, right, like, they would always look at it. They would always inspect it, do a visual, like, seriously, just point a camera at it and look at the thing. Does it look right from the outside? And then Starliner will go away, and then because of its egg-shaped orbit, it'll go back down. And then what it's going to do is make the egg shape, use a higher differential eccentricity here to basically get Starliner to go out in front of the station and kind of pull up in front of the station. And it could just go back down again if it wanted to, right? But once they get it so it looks like it flies up in front of the space station into the approach corridor, they'll execute a burn with Starliner and circularize it and get it to basically do what's called station keeping with the ISS. That basically means flying in formation. Also, there's a shot of Dragon. There's the Crew 4 Dragon right there. Which way would a craft burn to make an egg-shaped circle? Would that be normal? It's an elliptical orbit. It's not really egg-shaped. I use that to get the shape in your head, Flykin. It's an elliptical orbit. It's differential eccentricity. In what way would it burn? Well, think about it. Oh, there we go. There's a shot of her. What do you need to do? So in order to create eccentricity with your orbit, you need to burn at apogee or perigee, because the difference in height, the difference in the major axis between your apogee and perigee is what your eccentricity ends up being. Meaning that the bigger of the disparity between the highest point in your orbit and the lowest point in your orbit is how eccentric your orbit gets. Eccentric, think like how a camshaft is eccentric. And what is a camshaft? It's egg-shaped, right? Same idea. But once again, it's not necessarily egg-shaped. It's more of a stretched circle, an elliptical circle. And once again, that change in shape in orbital mechanics is called eccentricity. Eccentricity works on a scale between 0 and 1. Actually, it can go, you can have negative eccentricity, I guess technically. Once you get into negative eccentricity, that means you're going to hit the ground. Yeah, that's a suborbital, right? Then there's, once you're on orbit, there's eccentricity of 0, which means a perfect circle. And then eccentricity goes from 0 all the way to 1. Can anybody tell me what 1 is? If below 0 is suborbital, what's 1? Zero is a circle. What's 1? 1 is escape. You guys got it. That means you're leaving and you're not coming back. At least if you have the delta V, you can come back. If you don't have the delta V, you ain't coming back. Yep. So right now, Starliner is using differential eccentricity. It's in an egg-shaped orbit, and the ISS is in a circular orbit. And since they're really close to each other, it's a slight difference. And since they're close to each other, what it's going to look like is Starliner is going to look like it's going to fly up real close to the ISS, and then it's going to go away. There's some lightning down there because they're looking down at the ground. That's what those flashes are. Guys, if you're wondering what all the pixels, the pixels are here, well, they are pixels, and they are dead pixels because radiation up in space likes to really fry electronics over time. Yeah, the solar radiation is frying the camera. That's why there's all these bumps. What we're looking at right now is a shot from the ISS looking down at Starliner. That's Starliner right there, and it's nighttime. The ISS is in the nighttime right now, and you can see those cities and stuff right there. So we're looking down at Starliner with Earth behind it. This is the first time they've shown it.
This view of Starliner is going to gradually get bigger and bigger the closer it gets to the space station.
Where are they right now?
Starliner is currently 4.2 kilometers away from the International Space Station, closing in a little bit more than 4 meters per second.
Oh, they're...
And here in the control room, we can see some of the imagery coming from the Starliner cameras, which are themselves looking at the International Space Station, looking at the signature layout of the orbital laboratory with the signature solar arrays.
So right now, the ISS is over Kazakhstan. They're pretty much over Baikonur right now. So that may have not been an airplane. It probably is just a piece of dust and stuff. You gotta remember, guys, I know people love to, I want to believe, but a lot of the stuff that's floating out and around there is dirt, There's a lot of dirt, there's a lot of ice up there, there's all kinds of rocks. It's just a big mess. They're just small. It's like particles of sand almost. Yeah, they're a real pain in the butt, because if they hit your spacecraft, it's going like 4 or 5 times as fast as a rifle cartridge. So you gotta be careful with that.
Start stopwatch.
So they're over Kazakhstan right now.
Station copies and starting
My wife.
During OFT-1, Starliner did not get close enough to be seen by the International Space Station. But this time, Starliner's closing in and following its exact course.
Discovery, go at throttle up.
We are heading into... we're still about 23, a little bit less than 23 minutes away from the go, no-go for inbound
Little
fly around
pebbles.
1. And the burn itself is coming up in a little bit more than 27 minutes.
Yeah, if I can, maybe.
So you heard NASA astronaut Kjell Lengren, who is currently conducting the far-field monitoring steps.
So that's Starliner up here. I know it doesn't look like much, but it'll get close, and it'll get close pretty dang fast. Well, not like, but it'll get close pretty quick. Probably in the next, I don't know, 30 minutes, give or take, it'll start to get real close.
So task of setting a stopwatch to follow the Starliner spacecraft. It's a safety measure and a check to verify the GPS navigation systems aboard the Starliner spacecraft. Part of his far-field monitoring task.
Rizik, you seem to remember Dragon doing this a little bit faster. Well, DM1 was slow. The reason why this docking procedure is a little bit, it seems like it's a little bit slower, is because it's the first time. You don't want to rush. Don't rush it. First time. Don't do anything dumb, right? So I think this is one of Starliner's cameras.
Station Houston, all looks good. Reset stopwatch.
Looks like it's visualizing the ISS right there.
Resetting stopwatch.
That's right. Yep. Slow is fast. That's right. Slow is smooth. Smooth is fast. Because in space, you don't. Time isn't necessarily not on your side here. Like, what do they have to do? So what? The docking takes an extra hour. Who cares? That's nothing in the scheme of things. Don't be stupid, right? Like.
Station Houston, everything looking good. Reset stopwatch.
Okay. It's interesting. I just said, like, you don't need to necessarily worry.
Resetting stopwatch.
You don't need to necessarily worry about time when they're talking about resetting stopwatch for METs for points in the mission timeline. Nice. Question: when Starliner gets close in its egg orbit elliptical, if it docks on its flyby, will that impart its orbit onto the ISS? Equal and opposite reactions, Flykin, but it's not like it's going to come up out of the egg orbit and hit the ISS and dock to it. You didn't hear me right. It's going to get out in front and stop and match its orbital, or match its differential velocity. So it's basically going to fly in formation with it, and then they'll slowly move in. But yes,
look at
it will. That's why there's springs on the docking port to absorb that force.
As it steers Starliner through, and as it really finds helps Starliner find its way to the International Space Station.
They'll do a burn to match the orbit. That's what burn number 5 is.
Vesta is a state-of-the-art and highly complex navigation system designed by Boeing. It's what Starliner will use to autonomously dock with the International Space Station. VESTA stands for Vision-Based Electro-Optical Sensor Tracking Assembly. And here's how it works. The system consists of 2 laser-ranging sensors, 2 wide-field sensors, and 2 narrow-field sensors, all of which work together to guide Starliner slowly and safely to the station.
I think they're just going to fly close to it, Ordon.
Early in the rendezvous process, the sensors operate in long-range tracking mode.
That's what they're in right now.
Monitoring International Space Station from afar, when it still resembles a bright, star-like spot in the distance. As Starliner gets closer, the sensors pick up more details and are able to see the ISS clearly enough to determine its outline. This phase is known as silhouette mode. Then, in the final phases of docking, the space station is close enough for the Vesta sensors to switch to feature track, where they use exterior features on the docking port of the Harmony module, such as handrails, stickers, and reflectors to assess the capsule's position and attitude. Starliner's Vesta systems are programmed to recognize these features as relative points of navigation, enabling the spacecraft to determine exactly where it is and execute its docking procedures with great precision. Vesta also gives the ground teams
pretty
a
damn
highly
impressive,
accurate
actually.
understanding of Starliner's location relative to the space station as Starliner autonomously makes its way to the orbital laboratory.
It's all
Station
computers.
Houston, everything.
All right, that was a look at the Vesta package on the front board here.
So, see this camera over here? That's Vesta. That's very interesting that there's an autonomous system on here that physically looks. It looks for the docking port. It's looking for the ISS. That's actually really freaking cool. That means that Starliner doesn't need anything on the station to be able to know where the station is. It's literally looking for it like how you'd look for it with your eyes. And it's doing that automatically. This system seems very comparable to the terrain relative navigation system that worked with the Perseverance rover. Basically, when the Perseverance rover was going to land, right, they literally just had a camera looking down, and the computers were designed to just look around and be like, oh, that's a good flat spot, and land there. And it did it, which was really freaking cool. It has station relative navigation. Now, why is that cool? Well, that means Starliner doesn't need something fitted out on the thing it's trying to dock to. It just needs a similar docking port. As long as they tell the computers what to look for, that means you don't need any like antennas or anything on your space station so Starliner can find it. It'll just find it by visually looking. Meaning that, well, why would you make a system like that? Well, I don't know. This might be I might be reading too much into it, but if I was building a capsule, right, that was anticipating to dock to more than one type of station, I would build a system for it like that so it can dock to more than one type of station in the future. That's actually really cool. Let's see what Leah's saying.
Space station, as you've heard, that communication with the Capcom here in Mission Control Houston and Kjell Lindgren on the space station. Bob Hines is alongside him, helping with some of those steps as well.
It's a combination of things.
And while the spacecraft's docking profile is entirely autonomous, there are a few tasks that the crew on the space station will be remotely executing today that will allow Starliner to meet its flight test objectives for the OFT-2 mission. We've already seen one of those happen so far when Kjell Lindgren commanded Starliner's docking lights to come on, showing that they can have space-to-space commanding from the vehicle to another.
We are looking into it. Do not reset stopwatch.
I wish they wouldn't talk over the loops.
Copy. Not resetting the stopwatch. I can switch our side.
Other steps that the teams will be taking today is to execute a hold command at 250 meters. That'll also be sent from the space station.
Yeah, I know. No, not even Dragon has
a more
that.
hands-on process.
Dragon has
the automated docking that you'll see today is known as capture and berthing.
Dragon has a receiver on the ISS that a space shuttle, believe it or not, brought up. It's called Dragon Eye. So Dragon can see the station, and it can send data between the station and Dragon. That's how it docks. Starliner, I guess, doesn't need that, or at least it's not planned to need that, which is actually really cool.
They use this process. So the crew has ability to command a retreat to Starliner if there are issues, and the flight computer doesn't command that retreat on its own.
Of course there is, Gav. That's pretty neat.
We're testing out those capabilities by, as we mentioned earlier, turning those docking lights on and off, and then executing that hold command, showing that we can send specific directions to the vehicle.
Pretty cool.
And this crew has been training for Starliner's arrival while on board the space station. Some ways they do that include the approach and docking operations, emergency procedure review, as well as undocking and departure operations, and of course familiarization with contingencies.
Well, Bagel, it's not. This is pre-programmed for it to look for the ISS, but I mean, your question. So Starliner is likely using AI. I don't know. It's looking for it. It's looking to match the shape. I'm not necessarily sure if that's...
3 minutes. We have good vehicle time and frame counter on our command panel.
I'm not sure if that's necessarily...
Chill, and you can reset stopwatch at this time. We are getting some data.
Okay. I'm not necessarily sure that it's a neural net doing it, but I'm sure it could be if they wanted it to.
Confirmation here from the ground to the space station. They are receiving data from Starliner to the station again. Speaking of the Capcom, we've mentioned them a couple times today. That stands for Capsule Communicator, but contrary to the name, the Capcom here, Rob Hayhurst is not actually speaking to the Boeing Starliner capsule, but to the crew on the space station instead. And this name originated when we first started flying humans to space, which were all in capsules at that time, but it stuck around, and the Capcom's job is to relay info from the ground to crew members in space, which keeps communication between as few people as possible. Again, he's joined to the right today by NASA astronaut Sunny Williams. She's a Starliner systems expert as well and was able to watch the launch yesterday alongside her fellow astronauts Butch Wilmore and Mike Fink.
Well, the docking happened in daylight.
And standing there in the center of your screen is Flight Director Vincent LaCourte. He's gathering all of the data from teams here in the International Space Station Flight Control Room and keeping tabs on the space station. And in close communication with the room right across the hall where we have Gary and Steve, which is the room controlling Boeing Starliner.
Gary?
And the far field monitoring activity is complete.
Yeah, that's cool. Boeing's using one of...
great news. Thank you.
So this is the ISS Mission Control Center.
It's discontinuing timing at this time.
Down the hall from this...
Copy. Thanks for the help.
...is a Houston Mission Control Center. That's like the Mission Control Center.
Good news indeed that the far field monitoring test is complete.
That, like the shuttle
voices coming
which
from
is really cool.
Station. Again, Michelle Lindgren and Bob Hines doing most of the monitoring today ahead of Starliner's arrival.
Yeah, the Boeing is using
You've got a good look in that center screen here in Mission Control Houston of the really cool view that Starliner has of the International Space Station. That's through the Vesta system as it continues to get closer to the station. And again, as it makes its way to the space station, Starliner will be completing some demonstrations, those demos we keep mentioning.
If they show it, I'll tell you.
These allow the spacecraft to meet its flight test objectives for Orbital Flight Test 2. The first, Starliner completed a checkout of its navigation and orientation control systems. Once in orbit, flight control teams checked the star tracker and it looked at Vesta's narrow field cameras to determine that the spacecraft is looking at the correct stars. And now we have that amazing view right in the center screen that's also coming from Vesta. Starliner also performs early critical tests of critical on-orbit capabilities as Demo 2. These are thruster firing and abort sequences, so when the systems perform as expected, it proves they can be used if needed. It was also executed early in the rendezvous process, which was shortly after Starliner reached orbit yesterday. The third demo is for ground controllers to test the Vesta navigation systems that will guide Starliner toward the International Space Station's docking adapter. As we see, that's in work right now and will continue all the way through docking.
I'll answer that in a second, yes.
And the fourth demo is for astronauts on the space station to remotely turn on and off the docking lights, proving that the crew can command the spacecraft if needed, which was also successfully accomplished a little bit closer to the top of our broadcast.
Maybe a difficult question, so feel free to ignore me. What's the most important difference with the Dragon launches? Well, the most important difference is that it's a completely different vehicle and a completely different capsule. That's the honest truth. You don't want to have one way to get to the space station. The reason why is if something, God forbid, something happens with the only way for you to get to the ISS, then you're going to have some big problems. You don't want to strand people on the ISS, nor do you want to abandon the ISS either. The ISS is an expensive piece of equipment. It would be extremely difficult to replace that right now, considering the vehicle that launched it into space doesn't exist anymore, right? So, don't put all your eggs in one basket. Have two different ways to get up there on two different rockets, provided by commercial providers for a much lower price than it would be to do it in-house. If NASA designed their own spacecraft and then built it, it would probably be about as much as both of these vehicles combined with their rockets. This is an instance where the commercial market has a leg up on NASA. But I think that NASA has a leg up on commercial in going to the moon, considering that they've done it before. So this is a case where commercial is a really good idea. Boeing and SpaceX are able to deliver the same service, redundant dissimilar, for a lower price than what it would cost NASA to do it once by themselves. It makes a good bit of sense. Hello, have I made it in time? Yeah, of course. Yeah, you don't want to do something like what happened to Skylab. Exactly. So, oh, there we go.
Leah was mentioning. Now getting some views, now we're having good video communications from the station, so you can see some of the docking lights and navigation lights on the Starliner itself, the starboard and port lights shining right there in the distance. The International Space Station right now is currently over the Indian Ocean, west off the coast of Singapore. Because we didn't have a
spacecraft that could get to it, because it was between the Apollo program and the space shuttle. Its behavior is understood, from what I understand, Banana Time.
And you heard some of the communications there between the space station and ISS mission control here in Houston. Flight controllers looking at that comm situation, but we do have data coming back from the spacecraft, and telemetry coming back shows that the Starliner is a little bit more than 1.1 kilometers.
Watch and Russian laptop are ready for CST 100 arrival.
Houston copies, thanks.
Vesta really got a good picture of the ISS now.
What you're seeing here is a view from the Vesta system as the Starliner itself gets closer to the space station right now, just about a kilometer away. Some of the features, including the radiators and solar arrays, come a little bit more clearly. The outline itself is following the truss and the pressurized modules of the International Space Station itself, creating that T-shape that you see there. You can see that we're also pretty close to underneath the International Space Station. We're expecting to actually enter the approach ellipsoid, which we've been getting slightly closer to since that terminal phase initiation burn, which happened about a half hour ago. So we're close to underneath the station, but we'll expect to actually start that inbound fly run.
One good IR sensor, and just for your awareness, our data on all our displays remained constant and seemed to be valid the entire time while you were experiencing that comm loss.
And that is what we were expecting. Good to get your confirmation on that.
And that's good news reported from Bob Hines, who is continues to monitor the approach of Starliner to the International Space Station. They mentioned a loss of communication between the two spacecraft that they were tracking. We are getting data back, but Bob Hines reporting that he had continuous data throughout his monitoring procedures, and this verification is good news.
And we are about 12 seconds away from Starliner entering the approach ellipsoid, that imaginary boundary around the International Space Station. Starliner crossing about 1 kilometer from the International Space Station. And as you heard there,
Katanga, it actually can dock itself theoretically
as you heard there,
better than Dragon, which is actually really cool.
Gary was just noting that the International Space Station crew could keep a constant data link with the Starliner spacecraft. We do have data coming down, and Rendezvous reports that we are inside the AE. That's quoting the Rendezvous officer, of course, speaking about the Starliner spacecraft. As
Station Houston on 2, Starliner is inside the approach ellipsoid.
Station copies inside the approach ellipsoid.
Okay, they're inside the AE, which means the ISS is airspace. They went inside the airspace. It's not airspace.
Its precise
no
path,
air,
moving
that's what the approach
closer
means.
to the International Space Station.
So, fellas, this is the squiggly lines and everything that you're seeing right here is a system that's on board Starliner called Vesta. Vesta is a type of relative navigation. Relative navigation in spaceflight basically means Starliner has a camera on it and a bunch of lasers, and it's looking for the station. That's what That's what all these dots and stuff are here for. That's literally Starliner's onboard computers looking for the space station. And it will dock to the space station just by looking for it. Now, how does that work? Like any other spacecraft? Well, the shuttle had to be manually docked. So the Vesta on the space shuttle was somebody looking out the window with a joystick. Shuttle had to be manually docked. There was no autonomous docking with the space shuttle. Dragon does have an autonomous docking system. And not to say that one way is better than the other. They both work. They're dissimilar ways of docking to the station. Dragon needs a receptacle on the space station, though. The thing that Dragon uses that's mounted on the space station is called Dragon Eyes. It's so Dragon can see the station, and the station can see Dragon, and then that information is relayed to Dragon, and it autonomously docks. Boeing has seemed to have opted with Starliner to do something a little bit different, where they don't need anything on the ISS physically to dock this thing. The capsule will look for it, and it'll dock to it, which is actually kind of cool. It's like terrain relative navigation that was used on Perseverance when Perseverance went to land on Mars. It looked around. The computers on board physically had cameras looking around for a nice flat spot to land, and it automatically plotted a landing solution and landed the rover all on its own automatically, which is really freaking cool. That's actually really neat. Yeah, you could dock it to almost anything. You just got to tell it what to look for. You dock it to any station. You don't need to put any antennas up on the space station. That tells me that Starliner is designed to dock to more than one type of station. I'm just putting it out there. You wouldn't implement a system like that unless you were trying to dock it in the future to other stations. I'm just saying. That could be a little bit speculative on my part, but also there's this, What's on the right? I'm not sure what this camera is.
Station Houston on 2 for no 2 hatch closures.
I'm not sure gateway, guys. I'm thinking commercial low Earth orbit destinations. But
yeah, you are go for the no 2 hatch closures. Be advised that there's no ventilation into Columbus or Jim in case you needed to get something real quick before the hatches go closed.
Did Stuff and Dot Space go away? Yeah, I guess so. Interesting. Are they almost in daylight? About 15 minutes.
Officer reports that.
Yeah, I think it's the Star Tracker. I think you're right,
The authority to proceed to
Axiom,
keep out severe
maybe
entry.
Nova. Yeah.
That's important because it keeps Starliner on pace.
NASA has several
for
commercial
that,
space
inbound
stations
flight
planned,
around
Jim. They're
one
working with a bunch of different
burn that's
commercial
coming
partners
up.
for space
Starliner
stations.
is currently 704 meters from the International Space Station, maneuvering inside the approach ellipsoid.
The HLS, SpaceX got selected for a lunar lander,
Course,
but they have another program where they can select
to
another
the
person, and
International Space
I'm not sure if Boeing is entered in
Starliner's
that. I have to
speed
go look.
has slowed down quite a bit, moving
Yeah,
now
Jim.
less than a
Welcome in
meter
anytime,
a
buddy.
second, and that's as prescribed, so that Starliner stays on its path.
I'm sure Starliner has plans post Atlas V firing. Once again, you wouldn't spend the time to implement a system like this if you planned on launching it to more than one location. Currently, all of Starliner's contracted missions are to the ISS. There's 6 of them after the crew flight test. So we'll see Starliner go up to the station 7 more times after this one, at the very least. Hopefully, there's more if they extend the contract. However, there's going to be no Atlas V's after that. Maybe I'm reading too much into it, fellas, but I'm pretty sure Boeing has plans post Atlas V. Why would you implement a system like this that's easily designed to discern different stations and different types of docking systems? Why would you implement a system like that if you didn't have plans beyond the ISS with the capsule? I have a feeling we'll see Starliner fly on something else besides Atlas V, but I don't know what that is. And I'm going to bet you that Boeing probably has a good idea, and spoiler alert, I'm going to bet you that ULA probably has a good idea as well. But if that contract isn't negotiated, don't talk about it. Don't talk about it. You could frick it up. So, they said what they've been saying with Starliner is that It's contracted for 6 missions. And Tory Bruno has said, every time somebody asks him if Starliner's going to fly on Vulcan, he says if the customer wants them to, they'll do it. Oh, there's the moon.
Hold and the automatic retreat. We'll address those as we get past some of these inbound fly-around maneuvers.
It's the moon. Cool, huh? Oh, that's pretty neat. So, yeah, W, I think you're right. This is the star tracker. Literally, humans have been using the stars. Look at that. Humans have been using stars to navigate across the oceans for thousands of freaking years. In fact, the analog way of navigating around with a spacecraft is to use a naval sextant, which is a piece of equipment to measure distances between stars. Spacecraft use that, and they use a star tracker. Starliner literally looks at the stars and navigates via the stars because, you think like, oh, it's a spacecraft. What do you mean it's using the same navigation system as a damn sailboat? Yeah, pretty much. Only it's computerized. It's pretty much the same thing. Why would you do that? Well, if you think about it, they're not that much further or closer to said stars. This is 400 kilometers above the ocean. 400 kilometers doesn't make any difference if you're looking at the sky. The sky's still going to look the same. Even up there at night, the stars are going to be in the same spot. You're not that much closer, not that much further. So that's what works. So, yeah, they're using stars to track it. They use constellations. They have cameras that just point out, oh, there's the North Star. All right, I know where I am. Oh, there's the ISS. I can figure this out. That's what the computers on that thing are doing right now. That's actually really freaking cool. We've come a long way since the Gemini program, which was literally Buzz Aldrin with a grease pen writing star coordinates with a naval sextant by, looking out the damn window. Okay, the North Star's over there. Okay, turn to the left. Yeah, Buzz Aldrin was the guy that figured that one out. Spoiler alert. Yeah, that's why he was on the first flight out to the moon. He figured out how to navigate via the stars in space and what velocities to impart the vehicle to get a desired result. Yeah, no, that's pretty neat. Yeah, he navigated a Gemini spacecraft around by looking out the window.
15 seconds from the first inbound fly-around maneuver.
That's ridiculous. Starliner's doing that same thing, but it's doing it automatically.
Be a little bit overexposed. Cool, we'll see. The targeting looks good. Now about 5 seconds from the.
Imagine. Look out the window.
Ignition time.
Look out the window. What are you gonna do with this? Look out the window. Okay, what do you see? There's an Earth and there's the sky. Nope. No, you looked out and said.
One maneuver taking place.
It's a Unix system. I know this. Wow. Look at that. That's so cool. So if you're wondering why they're pulsing, they modulate thrust with the reaction control systems to make sure that they don't melt.
Good burn. That went just as it was supposed to. Produced great video.
They go.
That was spectacular. Yeah, we got to see the RCS thrusters.
That's freaking cool.
That enable that burn. We got to see them firing just in the right amount of sun and the right amount of exposure of the cameras themselves to give us those spectacular views.
Yeah, they pulse them to make sure the thrusters don't melt.
Reporting a good burn.
Because you got to think about it. They're in a vacuum. In a vacuum, there's no way to convect heat. You can't use the air as a medium to get rid of heat energy. So what does that mean? That means if you fire the thruster, all the heat energy that gets absorbed from the rocket engine firing stays inside of the nozzle. Now, you can radiate that heat out, but you can't convect it. Radiating takes a little bit more time. So what they do with the thrusters is they pulse them. That's why we saw it looked like a freaking nightclub up in there. Just yeah, I just dated myself. I know. Because they're trying to make sure that they don't melt the things. Well, not making sure. They don't want to do that. You don't want to melt your rocket engines. Remember, heat is really, really difficult to get rid of. And on top of heat being very difficult to get rid of in space, this side of the spacecraft is like, I don't know, plus 100 C, and that side is like minus 100 C. Thermals are such a big deal in space. How do you make something that can simultaneously be okay in 100 C and minus 100 C? Crazy, right?
10 p.m. Central Time.
Revs.
7:10 p.m. Eastern.
The bleeps, the sweeps, and the creeps. You know, the bleeps.
Rendezvous reports we're in good shape as far as the sensor readings and the information coming down from the spacecraft.
It's not all he's lost. It's not my stream without a Spaceballs reference. Hey, Sebby.
That movement is, of course, because having kicked off that inbound fly-around maneuver, the spacecraft is, while pointing its nose, pointing its sensors at the space station.
So cool. Look, the nose cone's open. They have a docking port cover that they installed. Look at that.
No two hatches are closed.
Copy, no two hatches closed.
No two hatch is closed, indicating that they're going to pressurize the vestibule for Yeah, they're not pressurizing the vestibule. The vestibule is unpressurized.
As
They've closed the CBM
Starliner
docking
flies
port.
just about 230 meters away from the station. Again, we just got past that first inbound fly-around maneuver. The voice you heard from the International Space Station, NASA astronaut Bob Hines confirming that the node 2 forward hatch is closed. They opened it just to circulate some air in between the pressurized mating adapter and get some things situated. They'll open it up once
Pretty
again.
much, Gav. Pain in the butt.
Probably not tonight, as their monitoring procedures take them through really late into the night Greenwich Mean Time. They will not open up the hatches to the Starliner once it docks until tomorrow morning, but they did get some of the activities situated in the pressurized mating adapter. So we'll see that hatch open again tomorrow and formally welcome Starliner to the station. Of course, many milestones to get to until we get to that moment. We're about 16 minutes from the second inbound fly-around maneuver.
For Jessica.
Rendezvous officer reports, of course we can see Starliner very good here from ISS,
American
and
fat
Rendezvous officer reports that Starliner sensors are picking up ever greater detail in the space station itself as Starliner looks on and makes its flight up into the
Lone Wolf. It's gonna do a flyby. The first flyby is like think about it like Starliner kind of circling to see where it needs to go, and then the second time around, Starliner will go where it needs to go and then dock. Yeah. Think about like how a pilot would fly around the runway and kind of look at it first and then figure out where to land.
Port 1.
Exactly like that. But Starliner is doing that automatically. It's doing that with its cameras on a system called Vesta,
And
which
also,
is
when you do the loading for item number
station relative navigation system, which is really freaking cool.
You can just anticipate 2 of 3 10.0 CTBs instead of 3 of 3.
Okay, copy 2 in SEP 6.02. I have a couple other questions for you if you've got time.
Okay, we should be going into full dateline here. It's getting to the Terminator. Because it's flying over Tasmania right now.
Steps 4.04 and 5.04 and 6.04.
Let me get one CSD call up, Jessica. Break for Shell. C2V2 data rate change in progress. Expect comm dropout in 5 minutes.
C2V2 is the communication system between the a vehicle. Between a vehicle, an incoming vehicle, and the station. He said a C2.
Right, sorry about that, Jessica. Please continue.
C2V2 bandwidth change, meaning that they're gonna change the bandwidth streams for the C2V2. C2V2, once again, that's the communication system between the capsule, an incoming vehicle, and the ISS.
5.04 and 6.04 mentions filling the CTVs with soft goods. Is there any any particular restrictions on what those soft goods are?
What a shot!
For return, presumably.
What a shot that is, huh? That's pretty good, man. That's pretty good. Hey, that's pretty good.
Station Houston on 2-4 Shell. You are go to perform step 2.
Not a weak arc, from what I understand. I can see your house. You don't live in Tasmania, Vin.
Step 2.
Yo, 5-year worm, let's go. Yeah, he did get the 60-monther. Nice.
Okay, and Houston, we have CST 100 in sight.
Look at Vesta's. Look at the resolution on the cameras on Vesta now. Holy crap. Starliner has an imaging system on board that's looking for the space station in real time. It's looking
from the ISS crew.
Think about it like this, like how if you were flying on board this spacecraft, you'd look out the window and be like, okay, the station's there, I gotta move in. It's Starliner's computers are doing that. Its computers are imaging the station and figuring out where the docking port is. Dude, that's actually really freaking cool, man.
Of Tasmania.
That's really cool.
We're about to cross over the southern Pacific Ocean.
That's really neat.
Starliner currently 510 meters away from the International Space Station. Relative speed continue to slow. Of course, Starliner moving very deliberately. About 8 minutes ago, it performed the inbound fly-around maneuver 1, and we have a second inbound fly-around coming up in 11 minutes and 45 seconds.
Yeah, Lone Wolf, it is a good idea, dude.
Some of the views on the big board here at Starliner Mission Control. On the right, the images from the International Space Station. Those are the cameras that have been giving us such wonderful views of
Based on purely aesthetics, do you like Dragon or Starliner
moves
better?
In towards the station.
Oh, I don't know, man.
And over on the left side,
it's carrying some
that's
supplies.
The imagery coming from the Starliner itself.
Look at the imaging on the left.
Vesta cameras that
Holy
are on the
crap,
nose of the vehicle.
That imaging system is good.
All of this working towards a docking opportunity. About 1 hour and 51 minutes.
It has a bunch of
from
lasers
now,
and stuff, Mav. They'll probably talk about it again.
6:10 p.m. Central Time.
Hey, Carver.
7:10 p.m. Eastern Time.
ISS and Starliner are currently approaching the southern coast of New Zealand. Peter Beck will somewhere look out his window and wave.
And on the center screen there is some of the graphic representation of the telemetry coming down from the vehicle, coming down from the Starliner as it moves into position around the International Space Station. Starliner
that man is playing Galaga.
Heading towards a docking, a connection with the forward port of the Harmony module that's in line with the velocity vector, or the V-bar, of the International Space Station.
That's a great link, Gordon. How do they protect the optoelectronic devices during the launch? Starliner has a retractable nose cone, Rem. It has a, think like a submarine hatch. It has a cover that's covering up all the cameras. Yeah, you'll see it if they show Starliner again. Think about kind of like Dragon's nose cone that opens up. It's kind of like that. FAO. Yeah. It's not FAC, it's FAO. I have a frequently asked question. Why is the toilet broken? Wait, no, sorry.
And we heard reports on the journey to the second inbound fly-around maneuver. That's coming up in about 9 minutes. The team's conducted a quick maintenance burn in between IF-1 and IF-2, like maintaining that course and getting us on the right trajectory for IF-2. Teams report a good maintenance burn, and again, we're trending towards a second inbound fly-around maneuver coming up in about 9 minutes.
I don't know. Yeah, that'd be cool. What stations in the Mission Control Center are dedicated to the ISS, and which ones can switch over to vehicle control? Nothing in this room is vehicle control, Flykin. This is the ISS Mission Control Center, and then there's the Starliner Mission Control Center. That is in a different room. They don't switch back and forth. Yeah, differences. Hey, Carvig, thanks for giving the sub to ArcSign. Right on, dude. Thank you. So all this is ISS dedicated. Yep. Did they control the space shuttle and the ISS from the same room? No. Nope. Actually, one of the Starliner control room is down the hall over there, and they're controlling Starliner from one of the old shuttle mission control rooms, which is actually really cool. How are they getting the feed from Starliner then?
As we look a little bit ahead, we see Starliner making its maneuver.
Is that a serious question? What do you mean? You're telling me that you don't think NASA has the capability of displaying another control center screen on their main screen? That guy did it, see? He came from the other room. He's like, I want to see Starliner. Click.
Lines up with that forward port, starts to move
No,
in.
it's in the next room. Dude, when I say it's down the hall, it's right over there.
It'll make a few.
You guys want this or
planned
gladiators?
Holds, 250
Gladiators.
meters. Then it'll move to
Wait, no. I'm sitting at this desk.
inside the 200-meter point. And then one of the demonstrations
controlling
is
the
actually that it retreat, that it shows that it can safely back away from the International Space Station. So after getting to that 180 point, it'll back out to 200.
Yes.
Then it'll move in again.
What?
And,
I'm trying to enjoy this.
have a couple of additional holds. All of these are just as expected. It's, with the spacecraft flying without any people on board, and it is flying autonomously just as it's supposed to do. But just want to demonstrate some of the systems on this orbital flight test.
I'm not playing Gallagher. I'm working. Jeez. See, I'm typing on this keyboard. Yes. Hey, I'm working here. All right, I'm not working here anymore.
You're getting a lot of telemetry here on some of the views you're seeing. The solid line on the bottom left is the Starliner
looking
itself.
at a green curtain. Shut
of
up,
course,
man.
we're coming up
You're
on
ruining
the
my
inbound
joke.
fly-around maneuver. I did want to address the top right, though. That sphere that you're seeing, it's almost like a protective shield from the telemetry.
These views.
Starliner, we saw that brief comm drop out. We've got good comm now.
Houston copies.
And that was Kjell Lindgren aboard the International Space Station, confirming they have a good link between the station itself and Starliner.
Man.
They're continuing to monitor Starliner's approach. He, Kjell Lindgren, as well as Bob
That's
Hines.
the approach ellipse right there.
That sphere, though, going back to the sort of force field shield that's around the International Space Station in that graphic, that's the keep out sphere. We'll see some of the demos that Steve was talking about, including the commanded hold outside of the keep out sphere. But one of the major demos that will be performing during the OFT-2 flight test is the Starliner itself will proceed towards that sphere, and it will not be given the authority to proceed past that sphere to test the vehicle's capability of an automatic retreat outside of the sphere. And we'll see that demonstration coming up shortly. Of course, a couple milestones to get through until we get there. We're less than 5 minutes away from the second inbound fly-around maneuver.
Yo, Richie, they can send people to space, but they still use Amiga graphics. Yeah, I know the graphics suck, dude, but honestly, these are the numbers that are being shown to us right from the spacecraft. Dude, I'll take the crappy graphics if this is in real time. If this was like a representation or an animation and these weren't the real things, then I'd be like, dude, this is the best you could do. But this is what, like, if you were on Starliner, right? If you were sitting in this capsule, this is what the screen would be showing, which is actually pretty freaking cool, man. I'll take that. That's actually really cool. These are the views that you would see inside of the capsule. So, you know what, man? I'll take this. This is cool. The graphics do suck. You're right, but I know. But since these are the real numbers, I'll take it, man. That's really cool. See? If I can see the loop, there's your differential eccentricity. That's the loop. It'll look like Starliner will go up and then go back down, and then it'll come up and then it'll dock. That's the top of the egg right there, so to speak. But this camera view shows how this would look relative to the ISS. So if the camera was like looking at the ISS as it went around, Starliner would look like it came up and did a cursive L because it's going up, right? And on the way up, it slows down, and then it speeds up again and goes away from the station because the closer you are to Earth, the faster you go because gravity. Yo, Sim, what's going on, man? How you doing? It's good to see you. We're just watching some live spacecraft data being streamed to us from NASA. Looks like Kerbal. No, this is like the actual telemetry downlink from Starliner, and it's about to dock to the ISS. Which, well, not about to. We're about an hour and a half out, but we're getting the live data and
after the
live like
inbound
interpolation of like what the capsule is doing, which is really freaking cool, man. I'm nerding out.
The international space station teams have already given their go for, which is approach corridor initiation. That gets us inside the keep out sphere. That's the green area,
yep.
And then of course in the mouth of Miss Pac-Man that you see there, that's the approach corridor that points towards the forward docking port of the International Space Station. We're not going to go straight in. Part of the demonstration is to get into the keep out sphere and then perform an automatic retreat, so we'll back out before proceeding back in with the green light to do so. But that's the approach corridor that we'll be aiming towards for docking later tonight. Still on track for that 6:10 p.m. Central Time docking.
Bow? So how does Starliner knows where it is? Because it knows where it isn't, obviously.
Rendezvous reports good targeting for the IF-2 burn for the inbound fly around 2 burn coming up. That burn coming up in 1 minute and 30 seconds. 90 seconds from now, Starliner remains on course.
I love Simcopter back in the day, the absolute best.
Well,
spoiler alert, Simcopter streams are like fine wine. They get better over time. Yeah, maybe you should go over there and peep one of his streams. Maybe you should go over there and peep it, you know. Like fine wine. It just gets better and better and better. No problem, Sim. Oh, you mean the game. You should still go check out Simcopter. He's actually really cool. But alright, cool. Simcopter was also a good game, yes. Awesome. Anyway, Sim. How's things, dude? Everything good? Uh-oh. Primo's here. We're in trouble.
Starliner currently 22 hours.
Oh.
Orbital Flight Test 2 mission to the International Space.
You do? Alright. I'm not in trouble, am I? Everything okay?
Everything's good.
Wait, you went when I asked you that question.
Everything's fine.
Yeah?
I love you. And that's all.
What did I do?
We've just had a heck of a day. And I love you.
Okay. You want to talk about it?
No.
You sure?
No. I don't want to talk about it. We're good. I love you.
Oh, okay. All right. I love you too. Are you sure?
Yeah, I'm fine.
How about now?
I need a drink, really. To be honest with you, I need a drink, but I'm fine.
Help!
So, ACI is approach corridor initiation burn.
Okay.
It is going to take place in 14 minutes.
JSpeed, I don't have time. I don't have time to. I want to see the docking. Okay. I don't have time for gyrations. Do you want to talk about it? Do you need me right now? It's better to be straightforward and very, very concise in your intentions. You know? Yeah, Baz, it's true. No. And also, fellas, ask 3 times. Trust me. Ask 3 times. All right? I don't give unsolicited advice often. Well, I do, but ask 3 times. Trust me on that one. Ask 3 times. Are you sure? Are you sure? Are you sure? You'll get the right answer after the 3rd time. If you're unsure. Okay?
I get it. Sometimes I say I'm fine and I'm not fine. This is not one of those times.
I know, baby. That's why I asked you 3 times. See? Works every time, man. Yeah, I know, Moo. That's funny. Yeah, she's all right. She's pretty cool.
Discovery,
I like her. Yeah. All right. So let's see. Where are we? Oh, Hokey gifted you a sub, Pythos. And then Chiron had a 4-monther in there too. Thanks, guys. I appreciate all the support. You should go check out Sim too, for what it's worth. Sim, I didn't see if you replied. Sorry, I got a little distracted. You know what I mean. Hey, Maverick. The unicorn brings you bits. Thank you. Greetings from Bagel Rabbit. Oh, hey, Forlorn. How are you? Did you see your last? Yeah, S. I could see you've developed your own ways of communication that have historically failed. It's like you didn't listen to me or something.
Discovery, go at throttle up.
Starliner now inside 500 meters to the International Space Station.
Bobbing 613 sub. Thank you.
478 to be precise.
No, Shadow, I'm good.
Meters. At a speed relative to the space station of 0.18 meters per second.
Okay.
Next burn coming up is going to be the approach corridor initiation burn, ACI. And that that burn will come up.
I want to watch this right now, maybe
minutes
later.
And 25 seconds.
I still don't understand the red line, blue line. Is that the safety check? Oh, they're your differential velocity on different axes. Okay, so red is like X, blue is Y, green is Z. Or no, green is blue. Green is forward and back. That's X, and then Y is up and down. That's blue, and then Z is left and right, and that's red. I think that's what it was. Those lines are just showing if you need to maneuver in one direction or another. Green is blue. What I'm saying is slow is fast, fast. No. It's got to be your bull. I tell you what, I can get a good look at a T-bone by butchering it. No. I can get a good look at a T-bone by hitting a butcher in the face, but I'd rather take his word for... No. It's not right. No. It's got to be your bull. Wow, you have derailed. No, I don't know what I'm doing, man. My head's about to explode. Did I tell you don't let anything distract you? Slow is smooth. Smooth is fast. I just killed Bambi. Boy. Sorry, man. But also, I got a little distracted by this shot here. There's definitely Starliner over there, and there's definitely Crew 4's Dragon docked to the ISS over there.
Now we're getting
that's
views,
pretty neat.
From the International Space Station in the distance. You can sort of see the Starliner maintaining a distance of about 500 meters away as it made its way through these past couple of inbound fly-around maneuvers. We did get confirmation there was a maintenance burn, standard course correction just to make sure it's on the right path.
Docking is in about an hour 20,
two inbound fly-around maneuvers, as well as a maintenance burn in between each of them. Flight controllers will continue to analyze, making sure that we're good for that approach corridor initiation burn that gets us in closer.
There is no cargo Dragon up here right now. That's Crew 4's Dragon, Hokey. Starliner is going to come up here for a week, and then SpaceX 25 is going to take its spot on the front of the ISS. That's partially the reason why Starliner hadn't flown in a little while. They missed the corridor because they needed to send a Dragon up because, you know, it turns out that humans still need to eat food when you're in space. I know, right? Weird concept. So that's part of the reason why it didn't launch last year. They missed the window. They didn't get it done in time, and then it had to sit for a little while. That's just a mouse. Yeah, no problem, Hokey. Yeah, Cargo Dragon is slated to go up. It's SpaceX 25. It should be launching in June, if I'm remembering that right. In fact, we can go take a look-see here on RocketLaunch.live. SpaceX 25 on the 7th. There it is. And then another Falcon 9 Transporter 5 on the 25th. which is next Wednesday. Sweet. Is the ISS and SpaceX, with that Crew Dragon, prepared if Starliner decide to switch this docking procedure to an impact experiment? I'm sure there is a contingency, Dave, somewhere, but you don't conduct spaceflight with the intention of failing, if that makes any sense. So, no. But yes, but also no. You really don't sit there and be like, oh, well, what if the capsule crashes into the station? That is a really bad way to engineer something. Well, you know, that means you're engineering for the capsule to not crash into the station. You know what that probably will end up doing? Either A, make the capsule work worse, or B, it will end up crashing into the station, because spaceflight kind of works like that. It's kind of very, it's not superstition, but you don't plan to fail. You know, you expect success, right? But always take into account that you could fail. But contingencies are called contingencies for that reason. It really depends on what happens and how it happens, you know? Your reaction is really dependent on, well, how your space mission, how the mission is going. So, Dave, there is a contingent. I'm sure there's something. I'm sure they'll find there's a contingency somewhere. There's a notebook somewhere that somebody has written in case, you know, something goes weird here. But they generally don't plan for that. You plan for the mission to go right. You don't plan for the mission to go wrong. That's a really bad way of doing things.
It's in 10 seconds from the next maneuver by the
What's the difference
Boeing
in velocity?
Starliner spacecraft. That's going to be the
during docking,
ACI,
like
the approach corridor initiation.
10
burn.
centimeters a second. It's like maybe a boop velocity at best, forlorn.
Starliner currently
the ISS can move,
just about
but
400 meters
not very quick
from the International Space Station, continuing to line up with that forward port of the Harmony module.
You have to be trained on the spacecraft, Burbs, but I'm sure cross-training is occurring in some
Now,
way,
as we
shape,
wait
or form.
for that approach corridor initiation burn, let's
For Starliner monitoring.
Yes, boop velocity. You know, boop.
Go ahead for Starliner monitoring.
Well, just wanted to give you a heads up. As we work through the rest of 1.102, Farmer will be on the comm for the remainder.
Hey, Pythos.
All right,
Hey,
Bob
Pythos.
has a comm.
Boop. Now what?
Takes two to tango. Chell Lindgren and Bob Hines currently working the monitoring procedures for the Boeing Starliner.
Over here. Boop.
They will be performing a series of demos, including a commanded hold coming up. It'll be Chell Lindgren at the helm, actually taking the
Stop!
actually sending the command.
Don't do that.
Bob Hines will be assisting, and he'll have the communications, so we'll be hearing his voice communicating to the teams here on the ground, including the International Space Station Capcom. Ray Hayhurst, or Rob Hayhurst, will be the voice from here in the ground, communicating to Bob Hines, who again is working with.
What the frick?
About 4.5 minutes to the approach corridor initiation. We're taking hashtag Ask NASA questions. If you have any questions about some of what's happening today, please send those along. The first one comes from Alejandro, who's asking about the crew sleep schedule. Do we know when the crew is scheduled to go to sleep today? Well, they're shifting today. There are 7 members of Expedition 67. The Roscosmos cosmonauts are currently in a pre-sleep period, though they will be around to help with some of the final docking procedures coming up here in the next couple of hours. The rest of the USOS side, which includes the NASA astronauts Chell Lindgren, Bob Hines, and Jessica Watkins, as well as the ESA, or European Space Agency astronaut Samantha Cristoforetti, will be in a delayed sleep period. So they'll have a late night as they work through the docking operations. The docking is currently scheduled for 6:10 p.m. Central Time, but that's right after 11 o'clock at night, if you're thinking GMT, 2300 GMT, so it's a late night. They will not open up the hatches later tonight. They'll save that for tomorrow. There's no rush. There's no crew inside, so we'll get through some of those procedures tomorrow. Keep sending your questions using the hashtag AskNASA as we take you through some of these next major milestones for OFT-2.
And we can see from this camera on the International Space Station that Starliner continues its methodical flight towards the forward port of the Harmony module of the International Space Station. Starliner's telemetry currently showing a distance of 350 meters from the orbiting laboratory, closing in at a rate of less than 1 meter per second, about 0.2 meters per second.
Meters? No, I'm good.
And we are 2 minutes from the ACI burn, from the approach corridor initiation burn. That's the next maneuver by Starliner. Rendezvous, in fact, just reported good targeting for the vehicle. That means that Starliner knows where it's going and knows where it is. Both very important things to do when you're executing this kind of a scenario. So.
Is that because it knows where it isn't? He said the thing!
90 seconds to the approach corridor initiation in the shot.
Because
you can see the International Space
Station. High five! High five!
The Crew Dragon that brought us 4 of the crew members aboard the International Space Station today, including
You did that on purpose. You did that on purpose.
Monitoring Starliner's approach. We're looking forward to having
But there's no air up there, Joseph.
Vehicles docked to the International Space Station. We have passed inbound fly around 2, are aiming for that number 7, that corridor approach. That's coming up in less than a minute now. That will lead us to those next major milestones, the 250-meter hold and the 200-meter hold, which are specifically demonstrations for this flight to test Starliner's capabilities as it makes its way towards the International Space Station. We're standing by 30 seconds until approach corridor initiation. Again, the teams are go to proceed into the keep out sphere. We do have that authority to proceed enabled on Starliner. 25 seconds.
So, if you picture just an imaginary cylinder that goes right here all the way up to the docking port, that's basically the runway. Them moving into the approach corridor is like a plane lining up with the runway, and then there's no touchdown. I mean, the touchdown is at the end of the runway.
10 seconds to the burn, 10 seconds to the approach corridor initiation.
Okay, let's see what we got. Watch right here.
Prop reports, burn is proceeding. And cutoff.
Oh, we really couldn't see it. They cut to an angle where we couldn't see those thrusters.
Rendezvous reports, good
right as it did it. That's good.
That means that Starliner is headed where it needs to be headed, which is to the forward port of the International Space Station.
Yeah, they cut to a camera that looks at the capsule almost straight on because the docking port is right there on the left. And, yeah.
Station Houston on 2. ACI burn was nominal. Starliner has begun force translation on the docking axis. Prepare for the hold command demo per 1.102 step 3 when Starliner reaches 255 meters.
Station copies good ACI burn and preparing for step 3 1.102 at 255 meters.
Good read.
Yeah, Filcher, hopefully should get a dock here in a second. So you're looking at a live shot off of the front of the ISS, and Starliner they're going to issue a hold command, and Starliner is kind of
you heard that. The command hold is coming up. We're about 270 meters, so the hold's coming up very shortly. For that command hold, we're going to take you over to the International Space Station Flight Control Room. Leah Cheshire standing by to take us through the command hold from the International Space Station. Leah.
Thanks, Gary. And again, as you mentioned, this hold is being commanded from the International Space Station. This is not a hold that is being commanded here on the ground. This will be sent from NASA astronaut Kjell Lindgren. He is aboard the International Space Station, arrived on the Crew 4 vehicle, as you mentioned earlier.
No, it's never
this
happened
is
yet.
known as Demo 5, so when we reach that 250-meter point, which we should be coming up on very shortly, away from the International Space Station, Starliner will demonstrate its ability to receive that hold command from the crew on the space station. So this allows us to send a command from space to space. It's similar to what we saw earlier when they turned on and off the docking lights. This is required to be completed for us to get the green light for Starliner to enter the keep out sphere. It's a 200-meter invisible line around the station. It helps the flight teams monitor the coming and going of visiting vehicles, and that's all visiting vehicles, whether they have crew or without.
Houston Station, hold command is sent.
Okay, there's the hold. When was the last time they used their arm to grab a vehicle and dock it that way? Like earlier this year to dock the Cygnus capsule that's up there?
Lindgren and Hines.
Like a couple months ago? Dream Chaser and Cygnus will still need the arm.
Confirmed. We'll pause here for about 5 minutes to perform demo objectives, and we will call you prior to resuming the approach.
Pretty much, Blinker, yeah.
And station copies, standing by.
Is the approach that the approach that Starliner is doing is same. It's very similar.
It's
to
great news from the team aboard the International Space Station, Lindgren and Hines,
How fast
confirming
are
that
they
the hold command
metric or
sent to
imperial?
Starliner is successful. Ground teams commanding, they see that as well.
Maybe someday, T-Man.
International Space Station and
Yes,
Starliner are about 250 meters away from one another, and Starliner will remain in that position for another 5 minutes while the teams continue to do checkouts.
17,500 miles an hour or 28,000 kilometers an hour is pretty much about low Earth orbit velocity. Keep in mind there is perturbing forces, so it's not 17,500 on the dot or 28,000 on the dot. It's like 27,930 something or whatever. But that's the gist of it. Yeah, about 7,600 meters a second, 7.6 kilometers a second. They're going fast, yeah. How fast the ISS and Starliner is going right now makes rifle cartridges look really slow. They're going about 4 or 5 times fast. Yeah, 4 times faster than a rifle cartridge, like a 308. They're really going fast.
Of Costa Rica and Nicaragua,
Actually,
about to fly over
it's more than 4 to 5
those
times.
countries.
But, yeah.
Still in this 250-meter hold away from the space station. Again, this command was sent from the space station itself, not from the ground, and it was not an automated command on Starliner.
Every month and a half, like, and it depends on how much perturbing forces.
Good LEDs on the panel.
Houston copies and concurs, and we're just looking at demo data right now.
Station copy.
Yeah, see? Current ISS speed is
Station confirms that the hold is
17,136.
steady, as well as the team on the ground concurs, and they still remain in that
27,577.
approximately 5-minute
Like I
hold
said,
while
not
they
exact,
look at
but
the
close
data
enough.
from the demo. Meanwhile, teams here in the International Space Station are discussing resuming from this hold.
Station is over you right now, T-Man. Are you in Honduras or something? No, the altitude. Oh, okay. This is the same one, Blinga. Yep, this is Calypso. I think. I always get it wrong.
This view shows
Okay, Jim.
Starliner
You do
getting
what you
lined
gotta do,
up
buddy.
with the Harmony forward port where it will dock in about an hour, just a little over an hour from now. An hour and about 20 minutes, that is.
Why is the ISS in that orbit? The ISS is in that orbit.
Houston on 2 for Farmer. Farmer, Houston CST will be commanding Starliner at 2154 to resume the approach. Starliner will automatically retreat at 182 meters and hold at 200 meters. You can monitor the retreat per step 4 in 1.102.
That will resume at 2154. Auto retreat per step 4 will monitor at 182 meters and retreat to 200.
Okay.
Good read.
The ISS is in that type of orbit, Snickers, so every country that participates in the ISS can launch to the ISS from their respective launch sites. So Russia, Japan, Europeans from French Guiana, and the U.S. from...
and a confirmation coming from the ground to the crew that the hold has been successful and the data's looking good. That is known as Demo 5, that hold at 250 meters. The next command for Starliner to resume its approach will come from the ground team rather than from the space station to the vehicle.
Did you really just forget KSC? No. I said Florida. Are you deaf? Bruh. I think because you hesitated when you said Florida.
And as we were just looking earlier and discussing this view from the space station of both Crew Dragon as well as Starliner, this will be the first time that we have both commercial crew providers' vehicles docked to the International Space Station.
Blue, don't you put this evil on me today. I'm tired, frick, man. Jesus.
Station Houston, Starliner has resumed the approach.
Well, that's cool, 619. Don't you put that evil on me.
The station copies, and we're showing the same.
Don't you put that evil on me, Ricky Bobby. Don't you put that evil on us. You are not paralyzed. I am so paralyzed.
And that the approach to resume, confirmation that approach has resumed for Starliner to make its way to its home on the International Space Station. That completes Demo 5. The vehicle now moving in from that 250 meter hold point. The next coming up will be Demo 6, and I'm going to toss it back across the hall to my colleagues Steve Seiseloff and Gary Jordan to walk us through what's next for the vehicle.
All right, thank you, Leah. It was good to see a good commanded hold from the International Space Station. Of course, Lindgren and Hein's job is not done. They're going to continue to monitor the Starliner's approach all throughout the way, but right now we're relying on the automatic software and the teams here on the ground to get us through the docking. Right now we're still scheduled for an on-time docking tonight, 6:10 p.m. Central Time.
Station Houston on 2 for Farmer. We are going to be expecting a little bit of Radicom, so if you don't hear from us when you see Starliner retreating, just keep monitoring.
I always throw movie references into my explanations, Schnoid. It makes it fun. Makes it fun, and I like movies. So.
Ground teams anticipating
a little bit of a
bad connection with communications from the ground, just about the time that they're anticipating that the Starliner itself will be crossing into the keep-out sphere. It's making a good pace right now at about 0.3 meters per second to get to that what the ISS Capcom identified as the 182 meter marker is when the Starliner is anticipated to make that automatic retreat. Right now, the Starliner is out 205 meters.
Okay.
Rendezvous officer reporting to flight director that the spacecraft is flying its trajectory just as it's supposed to.
This sticker is dangerous
so we'll
and
continue
impaling,
to see
but I
this
do love
picture
fake news.
come into better definition here as the Boeing Starliner spacecraft approaches the International Space Station on this orbital flight test 2.
What's my favorite
Coming up
movie
to
of all
the
time?
top of the hour, and what you're seeing here is the Starliner spacecraft as it approaches the International Space Station.
Blues Brothers?
On orbital
Blues
flight
Brothers.
test 2. This is the...
and then like October Sky, like right after that, because space.
This mission is being flown without astronauts aboard the Starliner spacecraft. There are astronauts aboard the International Space Station. These images are coming from cameras
hold off on the movies.
on
I'll throw the movie
International
quotes in,
Space
but I want to
Station.
watch this.
Looking at Starliner, which is at currently a distance of about 186 meters.
Boeing designed this capsule.
Starliner's going to pause its approach at the
see the little hatch that's open on the side, the aero cover?
180-meter point. Then it's going to fire
New
its
Shepard got
reaction
pushed,
control system thrusters and back away from the International Space Station. That's a demonstration of its ability. And we have word from Rendezvous that Starliner is executing Demo 6. It is retreating from the International Space Station just as it's supposed to.
Little pulse of the engines here.
Starliner is retreating. Expect Starliner to hold at 200 meters.
Station copy.
This retreat is going to take Starliner just to the edge of the keep-out sphere, which is that imaginary boundary about 200 meters from the space station. This is all taking place 23 hours, 4 minutes, and 17 seconds after Starliner lifted off from Cape Canaveral Space Force Station in Florida yesterday evening.
Well, guys, give me 1 second. I'll be right back.
Everything's looking good. We're just passing 190 meters again. The Starliner is automatically going to hold
not emotional
at,
damage. I need to be right back.
As part of this test.
There we go. Emotional damage. No, there we go. I'll be right back.
You can see some of the telemetry on the board. On the left screen there is the VESTA system, the optical system on board the Starliner that's looking at the International Space Station. So that's the view from the spacecraft itself. We're getting some good telemetry in the middle screen there. Sort of the mesh sphere that's surrounding the outline of the International Space Station. In the middle board there is the keep-out sphere. It's that mesh sphere that we touched and now are retreating from to 200 meters. We're now awaiting the confirmation that we're holding.
Houston Station, we're showing vehicle mode is hold at 202 meters.
Houston copies and concurs.
Good reports from the International Space Station. That was Bob Hines, goes by the call sign Farmer, confirming that from the International Space Station side, they are seeing a hold, as well as the teams on the ground.
Station Houston, Starliner is holding at 200. Perform monitoring per step 5 and 1.102.
And station copies go for monitoring step 5, 1.102.
station Houston on 2 for assistance with WIF 17.
Okay, go ahead, send it.
Yeah, looking at the overlay down here, we think that we might need a calibration. We would like for you to turn on the calibration per step 3.3.2 in the setup procedure 1.401.
Okay, copy that. We have the calibration overlay up at this time. I don't have light mode on structure to be able to calibrate.
Okay, Joe, I understand. If you could just leave it as is, we think we have what we need, but we're checking.
Okay, copy.
And one of our Ask NASA questions came in from Russell, asking what is in the Starliner capsule. Is there a zero gravity indicator? Well, you know, Starliner, as fate would have it, we have a lot of imagery of some of the cargo that is going up on Starliner. It was packed here on Earth, of course, and loaded in. There's the biggest bit of it is Rosie the Rocketeer, and what you're seeing there is some of the commemorative material that has gone up. Those are university flags, and we have some medallions commemorating Rosie the Rocketeer, who is named after Rosie the Riveter, and also continuing the tradition of taking tree seeds into orbit. Of course, we've packed a number of flags and some mission patches, all packed very carefully and weighed out and loaded into the spacecraft just as it needs to be to keep the weight where it needs to be, keep the balance perfect. You can see some of that packing activity going on here. That is there in Florida at the Commercial Crew and Cargo Processing Facility, the C3PF. And once some of the cargo is taken off by the ISS crew, the astronauts there are also going to load some used equipment into Starliner. Starliner is going to bring that home. That's going to include 3 NORS tanks, NORS, N-O-R-S. That's the nitrogen oxygen replenishment system. That's the basically the source of air on the International Space Station for the crew. You know, whenever a spacecraft arrives, you want to make sure to put it to good use, and Starliner will be coming back. Starliner will be coming back and landing in the American Southwest. Of course, that's quite a few days away, and at this moment we are carefully following as Starliner moves in towards the International Space Station.
You heard that about?
And we showed some of the imagery of the cargo, and we also have some of the footage of Rosie herself. She is in the commander's seat. It's an anthropomorphic test device, really set up there so that we can see how the spacecraft behaves in relation to crew themselves, how a person sitting in the Starliner, what kind of situations, what kind of circumstances it'll be. It's a good ride up and should be a smooth ride down. There you see the mission patch that Rosie the Rocketeer is wearing. That's a unique mission logo for this NASA and Boeing Orbital Flight Test 2 mission, and you of course can see the Rosie patch, and she is outfitted with the signature scarf for Rosie. Of course, Rosie the Rocketeer and Rosie the Riveter, named after the women from who worked in the factories during World War II, building airplanes, including at Boeing, of course. So that was a quick look at some of the things going up, and the International Space Station crew will get their own close-up look as they unpack some of that material and load new stuff to return back home.
Thanks, Steve. Keep sending in your questions using the hashtag AskNASA. We'll continue to clarify more about this mission as we continue our coverage to head towards docking. Right now, the Starliner spacecraft itself is holding at 200 meters. Right now, at about 210. This is after one of the demonstrations of the Starliner spacecraft to automatically retreat from the 182-meter keep-out sphere. That performed successfully. They're just continuing to hold before sending the Starliner in once again past the keep-out sphere to the next milestone, which is the 10-meter hold.
Wait a minute. Somebody just asked where you can watch
for about
live?
12 more minutes. So keep sending in those questions.
Do you want the link to NASA TV, Ice Mage? No, but see, we have a magic trick, though. We can fast forward. Ready?
Station Houston, Space Ground 2 for Starliner status.
I'll be right back again. 1 second, guys.
For station.
Hey, Farmer, we have been losing a little bit of comm on one of the antennas on Starliner. We will need to use this antenna again at 2215. If it does not come up, we expect to have a 7-minute LOS until we come up on the next antenna. So it just may delay the time to when we would resume the approach. We expect that we can make up that short amount of time by decreasing the 90-meter hold time.
Okay, station copies all.
And I didn't say it before.
2215 we'll expect a 7-minute LOS, and copy all on making up the time of the 90-meter hold.
All good copy? Yeah, and during that LOS, of course, you will continue to be monitoring.
Station copies all.
Alright. I'm back. I had popcorn for a snack. And there was a piece of popcorn. You know when the kernel gets stuck in your teeth? Yeah. Yep. I had to deal with that, like, very quickly. Going in the nighttime, it'll be about 40 minutes here. Well, depending on where the ISS is right now. About 40 minutes until daylight again. Nice, Leglander. That's cool. So I heard them saying there was something a little...
we were seeing the
weird with the antenna.
View of the Starliner spacecraft get a little bit darker. The station is 261 statute miles over the northern border of Hungary, and it is nighttime there, so we'll see dimmer views for a little bit until we come out of the Terminator line and start seeing some sunlit views of Starliner once again. Everything's trending well. We're just, you heard that communications up from the International Space Station Capcom, just holding here for just a little bit. The Vesta system, of course, is a complicated system that has uses optical navigation, and so we really have to look at specific sunlight constraints. The sun itself changes angles as the International Space Station and Starliner orbit every 90 minutes around the Earth, and that angle can change, so they're just waiting for just the right Goldilocks conditions of lighting, and so they're deciding to wait out here at the 200-meter hold. So we're standing by, waiting for the go to proceed into the keep-out sphere. The next hold will be at the 10-meter marker.
Everything is looking good, Rockman. Been a couple of small things that teams are working here and there, but it's really not bad.
Flight Director Ed Van Cise advising his team to get ready to resume the approach. Starliner currently basically hovering just in front of the International Space Station, about 206 meters. Rendezvous's given his go.
Oh, excuse me.
Flight polling the other controllers here and their specialties to make sure all of those systems are ready. So far, all looking good to resume this approach. They're going to move Starliner, as Gary was saying, move it up to the 90-meter point, and then they're going to hold. That's a planned hold. Again, there's a series of holds during this approach. This is an orbital flight test.
Pushing buttons? Nah. If I was actually sitting there, I'd be like this. I'm like, I'm not touching nothing.
And of course, in this current period of orbital darkness, that's why we're not getting such good imagery, but that's going to change in a little bit. After all, when you're going around the world at 17,500 miles an hour, you can do a complete loop around the planet in a little bit more than 90 minutes. So we should be out of darkness in a bit. And
that man is playing Galaga.
Good imagery again. And in the meantime, you can see some of the graphics that the control team sees up on the big board here at Starliner Mission Control in Houston.
Show us. I understood that reference, which in itself is a reference to the reference that I'm referencing. Nice background. Oh yeah? Yeah, it's pretty good. It's pretty good. Pretty good background. All right, so Starliner is currently holding at the edge of the keep-out sphere. That is basically the no-fly zone that's directly around the ISS. You can see it kind of visualized by the geodesic sphere right here that's on the screen. And Starliner is holding right at the edge, and the ISS is obviously, the center of the ISS is at the center of the sphere. The reason why it's holding here is because it's demonstrating that it can station keep. Now, what's station keeping? Station keeping is basically flying in formation with something in space. That's a little bit more difficult to do than how you might think. See, it's just station keeping, just maintaining the same distance over the same period of time. The reason why station keeping is a little bit different, because theoretically, if Starliner is out in front of the space station a little bit, in order to stay relative, you're going to need to constantly be adjusting your orbit. So station keeping is actually, flying in formation in space, actually not the easiest thing to do. They commanded Starliner Starliner did an automatic hold, and now the computers they pre-programmed the computers to just basically hold here. And now Starliner is basically waiting for them to give them the go to finish running the program and dock to the space station. Right now, what the teams are doing is basically just looking over everything on Starliner, make sure everything is good before you get that thing near the station. You don't want to screw that up. These are projectors. Those are screens up there. What happens if something goes into the no-fly zone? Micrometeorites do pass into the no-fly zone every once in a while, Schnoid. You just basically have to minimize risk. Fortunately, you know, if something, they'll see if something big is coming, and they'll move the station out of the way. But yeah, there are some things that are harder to maneuver around than others. But yeah, if an unidentified spacecraft comes in the keep-out sphere, I guess they could get angry. You know, I want to believe. But you got to remember, the ISS is a spacecraft. It has thrusters on it, not very powerful thrusters, but thrusters nonetheless, and it can maneuver out of the way if it needs to.
Station Houston on 2 for Starliner status.
Z1 trust segment
right now, but we're working through a couple of small issues, so we're going to continue to hold here.
Yeah, McCory, yeah. I'm looking through chat, Novacon. I don't know what you want me to see. What velocity is Starliner going at? 17,500 miles an hour, give or take. About 27, it's more like 17,200 right now, but 27,602 is the speed that's being reported for the ISS telemetry right now. I have both screens up so you can see where everything is.
So you heard that call from the International Space Station, Capcom. That's Rob
it's up there on the left.
Relaying up to Bob Hines, who's right next to Kjell Lindgren. They're monitoring the Starliner's approach to the International Space Station. It's currently at a 200-meter hold, as was designed with the automatic retreat once it hit the keep-out sphere at about 182 meters. It's still holding there. The teams are just assessing to make sure that the Starliner itself is all in tip-top shape before they go ahead and proceed into the keep-out sphere. There are several lighting stops along or hold points along the way to check for lighting and other conditions. The first one at 90, and then of course the big ones at 10 meters. And we'll just wait for the teams to make sure that everything is go before we proceed in. We are still within the window to make that docking time later tonight. We're targeting 6:10 p.m. Central Time. There is some flexibility there in terms of timing, but right now we're still within a good window.
Why have we had seemingly less information about this test than the Dragon flight test? Felt really quiet after launch. I don't know, because Boeing needs to up their PR game. Like, what do you want me to say? we have live telemetry being streamed for Starliner over there on the center screen. Like, it's been pretty good for me. I don't know what you're talking about, dude. I don't know how to answer that question, Trojan. Like, what do you want me to like? I mean, Boeing has been a little bit quiet, but they did the pressers and everything. They said the issues that they were working, and like, Maybe they don't update it every 5 seconds on their Twitter account, or, you know, the cast is not as good. I wouldn't say not as good. It's just a little bit different than what we're used to with SpaceX, right? But everything seems okay here. Yeah, hypersonic, it's flight controllers, man. Anyway, sorry, just got here if you answered this, but is Starliner and Dragon do the same thing? They're redundant, dissimilar, Justice, which means yes, they do the same thing, because having one spacecraft to get into space has not worked out for NASA in the past. It's much better having two. And what's better than one? Two. And if they're totally different vehicles launching on totally different rockets, if something does, you know, happen with one or the other and they have to ground a vehicle, they still have a way to get up there to their multi-billion-dollar space station. See what I'm talking about? It's probably a good idea. Yeah, Aqua, I agree with you. No, Stone, you haven't. Thanks for the answer. No problem, Justice. Yeah. What's this I heard about water in a spacesuit? I think that's happened before. What do you think is causing it? Water in the spacesuits? Condensation from the thermal control systems, Mycon? That does happen. It happens. Yeah. Are Soyuz vehicles raising the ISS altitude? Tingmei Progress does. Or Zvezda, the service module for the space station. Soyuz, they generally don't use the Soyuz for boosting. They use the uncrewed spacecraft. They use Progress. Attached to the back of the space station, which is attached to Zvezda. But yeah, they can do that. Yeah, pretty much switching, right? 2 is 1 and 1 is none. Yep. I just read that there's some problems. What are they? They had some stuff going, some weird stuff with the sensors for the orbital maneuvering and control thrusters, but they apparently understood the behavior, and Starliner's working just fine. Sure, Killer Fun, yeah. What's the perfect docking speed? T-Man, there's no perfect docking speed. You ideally want your speed to be 0. Now, that's the difference in speed between the ISS and Starliner. Remember, docking isn't like Starliner moving to the ISS. They're both orbiting up in space. The key is to match the velocity of the ISS. But you want to match the velocity of the ISS right when the docking port slips in. So there's no real perfect speed. We have trampoline and a broomstick, Kyron, yes. Trampoline and broomstick, okay? No problem, Ting. It's so stupid how the headlines are panic NASA cancels spacewalks. Yeah, everybody's got to make a story out of something, Mycon. Helmet fills with water. Yeah, the reality of that situation, Mycon, is that one of the astronauts saw a little droplet of water moving around, and they stopped out of an abundance of caution. There's no emergency here. Doing spaceflight. Now, being spaceflight, I am spaceflight. No. Doing spaceflight operations, especially something like an EVA, is about hedging your bets and minimizing risk. Look, if the suit has a droplet floating around in it, you really want to make sure that it doesn't do that when someone's in it out there. They could asphyxiate. That's not a good thing. If the suit is not meant to leak water and it's leaking water, don't go outside. Why? What happened? No, but Mycon, what happens is that every once in a while, somebody who doesn't understand spaceflight, you know, and is just browsing NASA.gov or something, sees that, you know, an article, a press release saying that, you know, oh, we found some water in the spacesuit, which is a pretty common occurrence. That happens from time to time. It's obviously not ideal behavior, but it does happen. You know, we're just going to make sure that everything is good before we go out and do the next EVA, so the EVA is postponed for now. Somebody will read that and they'll think it's, oh my gosh, the helmet's full of, those spacesuits are full of water. How's NASA going to do this? They're canceling EVAs. We're all screwed. When in reality, they don't understand the level of risk aversion that NASA has when it comes to this stuff. They're very careful on purpose. They didn't nobody ever stopped and thought, oh, NASA might know what the heck they're doing. Do you think does it sound like NASA when somebody would just make a press release saying, oh, I don't know why this is happening. I don't know what's going on. We're all going to die. Does that sound like NASA to you? See what I'm talking about? Yeah, it's just people that don't understand spaceflight. And to be fair, it's hard to understand it. It's a really weird way of thinking how you go about conducting spaceflight operations. It's very strange. What I try to do is explain it. I mean, it might as well be freaking Japanese, man.
Station Houston, Space Ground 2 for Starliner status.
It happened again, Swell.
Wanted to bring you up to date with what we were talking about down here. With 17, we are looking at the difference between the little TY in the middle of the circle and where Starliner actually is. Right now, we're in great shape. Starliner's within the circle, so keep monitoring. We're just trying to get comfortable with why we understand that there is an offset there.
Okay, copy all. We were actually just thinking about calling you about the same thing. Seems like that T is staying in the same spot pretty much the whole time, and then we're watching Dragon we're watching Starliner drift around. So it is obviously holding stable inside the corridor, and we'll continue watching. And our pop is looking good as well.
Oops.
Rendezvous. Thanks.
Rendezvous proximity and docking operations and docking. He said our pod is looking good right now, meaning that Starliner is just kind of
what you're seeing on your screen now what was relayed up to the crew. The teams, again, we are holding at 200 meters right outside the keep-out sphere, waiting for that go to proceed inside of the keep-out sphere. The teams, both on the International Space Station side as well as the Starliner side in each respective control rooms, as well as the International Space Station team monitoring from aboard the orbiting complex that includes Bob Hines and Kjell Lindgren. They're all watching their respective data. From here, you can see the monitoring tool that the crew is looking at. In the middle of the circle is where the Starliner is supposed to be, and you can see the just a little bit lower and to the right is where the Starliner actually is. You can see the docking and navigation lights on the forward end of the Boeing Starliner. They just want to make sure that they understand some of the data before they go ahead and give that go to proceed inside the keep-out sphere. So the teams here on the ground, as well as the International Space Station, will continue to monitor and make sure they completely understand the data before going ahead and giving that go.
What propellant does Starliner use for RCS? Nitrogen tetroxide and monomethyl hydrazine. Same as Dragon, Farwing, yeah. Most spacecraft use hypergolic propellants like that up there. The reason why they do that is because MMH and NTO are hypergols, meaning that if they touch each other, they explode. So that makes it so the engines that you put, like the RCS, the reaction control systems, the little thrusters on the spacecraft that make it turn around and move in space, require a very, very simple rocket engine. It's a very, very simple piece of equipment. It's just basically two fuel injectors, like a fuel injector on a car, hitting a rocket engine, and then when the liquids hit each other, they combust. And that causes an energy release, and that thruster makes thrust. It's very simple. You can keep your thruster design very, very simple that way. Dragon uses this, Starliner uses this, Soyuz uses something like it, the Russian equivalent of it. The shuttle used NTO and MMH. Gemini did. Everybody uses those. The thing about NTO and MMH is that they're toxic. So you gotta be careful. But up in space, it's not that big of a deal because it's on the service module that's behind you, right? So you don't need to worry about it too much. But another reason why they like using these is because these propellants don't boil off. They basically stay liquid even at higher temperatures and lower temperatures. They don't freeze and turn into solid NTO or solid MMH. They basically stay as liquid on spacecraft for long periods of time. They have a really, really long shelf life. And some commodities on spacecraft don't. Like liquid oxygen, for instance. Liquid oxygen boils off because in order for oxygen to exist as a liquid, you have to keep it at really, really low temperature. And to keep it at really, really low temperature, you want to keep it and also you need to keep it at high pressure so it feeds in the tank correctly. So it does like to boil. And if it boils too much, you overpressurize the tank. It'll eventually, the whole tank will either overpressurize and pop or turn into gas inside. Yeah, real big pain in the butt. Hydrazine, so monomethylhydrazine and nitrogen tetroxide, you don't have to worry about that. They'll just stay as nice, they'll stay as liquid inside of their tank for a pretty dang long time. You do kind of have to be careful about NTO though. NTO, if nitrogen tetroxide gets like it backflows in the system, you got a big problem. Like you got to make sure, because NTO is super corrosive. It really, you got to be careful with it. It really likes to rust things. There's a lot of oxygen in nitrogen tetroxide, so it does rust stuff if you're not careful. You got to be careful. And that happened one time, not with this capsule, but yeah, it happened one time on another spacecraft. Not fun. What motors are used for launch escape? There are 4 motors that are in the back of Starliner's service module that are the launch escape system. They're on the bottom, like this is a Dragon model, but they're down here and they're facing down. You'll see them in a Starliner animation. They're on the back, like on the back plate of the service module. I think they're RS-88s, if I'm remembering correctly.
All right, we're continuing to monitor.
They also use monomethylhydrazine and nitrogen tetroxide.
The teams believe they have a good understanding and confidence to go ahead and proceed into the keep-out sphere. Words should be coming up from the International Space Station Capcom here shortly to describe a discrepancy in the data, more so really the graphics that are being drawn around Starliner versus Starliner itself, and we'll have the International Space Station Capcom describe that. In the meantime, the station and Starliner teams are polling to make sure that they are go to proceed inside the keep-out sphere. So we'll wait for that word from the Capcom.
What does cycles mean? Do they have the same cycles as a LOX engine? What does that mean, Hypers? I don't know what you mean. How many times can you turn it on and turn it off? Yeah, no, that's not the right question to ask, dude. It's really about design. RCS generally can survive more firings for longer period of times. But the funny thing is about RCS is that they modulate it. They modulate it for thermal control so they don't melt the engine in space because it's really hard to get rid of heat. So if we do see Starliner firing its RCS again, it'll go sound like a type. Well, I was about to say it'll sound like a typewriter. If we were on board the spacecraft, it would sound like a typewriter. But just picture in your head that it's making the same noise as the typewriter, because that's pretty much what it sounds like. Basically, other than the ignition, do the engines work the same? Yeah, of course. It's got a combustion chamber with 2 fuel injectors, and then it's got a throat and a nozzle. Yeah, of course it does. Why would it be different? Yeah, man. Mm-hmm. Bada boom. Yep. Just remember, guys, you're stuck at the airport terminal gate. All you got to do is show them the multi-pass. Just got to show them the multi-pass. Yeah, she knows it's a multi-pass. All right, anyway, we're in love. Multi-pass. All right, anyway. Yeah, she knows it's a multi-pass. All right, we newlyweds just met. I didn't come here to play Pumbaa on the comm loops. Tomorrow from 5 to 7, you're going to dock the module yourself. Green? Double green. TSA might not get that joke.
Station Houston Space Ground 2 for Starliner status.
Discovery, go at throttle up.
Met, go. What's up, dude?
For station. So the what we've come up with is the T that you see in the middle of the circle. For whatever reason, that is not correct. We do have very good confidence that Starliner is within the circle, and as long as you see Starliner in the circle, we are in a good config. We can verify that through RPOP and ground telemetry that it is in a good config.
RPOP is rendezvous proximity
Station
operations.
And we're comfortable with that and concur.
Okay, so it looks like they're getting a little bit of junk data off of Starliner. That could be.
Okay, and with that, we are going to resume the approach shortly.
Okay. NASA shouldn't let them approach if the nav is screwy. Well, yeah, drummer, you'd think that, but NASA literally just said it was okay. So that's who you were just looking at. It's funny how, you know, the guy.
All right, so those words
said the opposite
projected
of what you
to the
said.
crew. The International Space Station Flight Director Vincent Lecourt has given his go to proceed inside the keep-out sphere. What's happening here is some of the data that's being fed to the system that you're seeing is projecting a false green circle and an indicator. But the teams have identified enough confidence in the relative position of Starliner and the data that they're seeing on the ground that they know where Starliner is. So the green circle is off position instead of Starliner. With that, they have the confidence that they need, and so does the crew, to go ahead and proceed inside the keep-out sphere. We'll be seeing that moment here soon. And we have it. Starliner is moving inside 200 meters now.
I really wish I could see that. Oh.
Station Houston, Starliner has resumed the approach.
Okay.
Perform step 6 in 1.102.
Here we go. They can confirm data other ways. Yeah, up. They have
step 6, and we see resume approach.
They have redundant
Agreed.
systems
and also,
on board.
Farmer, once we get to the 90-meter hold, we will reassess things there and come up with a new time for continuing the approach.
At what point is the engine no longer RCS? An example being the huge mothership using RS-25s as its engines for control.
Starliner is on the move. Next stop, 90 meters. Starliner moving in towards the International Space Station. Keep out sphere entry coming up less.
The direction
coming
the
up in about a minute
pointing,
and 15 seconds.
Pretty good indicator.
Starliner firing its thrusters to move in towards the forward port of the Harmony node of the International Space Station.
Okay.
All the systems on Starliner performing well. Starliner uses a integrated suite for navigation. You can kind of it uses a space GPS system. Well, I should say a GPS system that's designed to work in space. We call it SIGI.
SIGI!
And that's basically how Starliner tells where in space it is. And then it uses the Vesta cameras and sensors to look at its destination, which is the International Space Station. And you can think of it as basically the spacecraft is driving itself to the International Space Station in the same way a person drives their car on a long trip, using a Maps app to kind of get into the city, get onto the street that they're going to, but then using their eyes to pull into the driveway. Well, in this case, the driveway is the International.
Starliner has entered the keep-out sphere.
Okay, she's in the keep-out sphere. We're within 200 meters.
Discovery.
Forfa, 51-month resub.
So that confirmation that Starliner has
It's
entered
dark,
the keep-out
gentlemen.
sphere. And just to complete that analogy, in this case, Starliner's driveway is the forward port of the International Space Station.
See, this
is a big moment for the.
This big cone is what's called the approach corridor, guys. I don't know what I got top driveway. This is more like a runway. It's more like a runway for Starliner. It's on final approach right now. Just think an airplane landing on a runway. The thing is that the runway is over here. It's just a docking port. You don't need a big long runway for the capsule to dock. It just needs a docking port. This is the approach, right? I know because it's called the approach corridor. I know. Funny story. So, Starliner's inside of that keep-out sphere. You should see minute corrections by the reaction control systems here. This is the heading relative. Starliner's local orientation is basically relative with the ground. So the bottom of Starliner is facing towards Earth, and the top of the capsule is facing towards space, right? So if you were sitting in the capsule right now, your legs would be towards the Earth, and your head would be towards space. It's oriented relative to the ground correctly. I mean, keep in mind, there's no up, down, left, right in space. You have to orient to something. So oriented to the ground, if you look at that nav ball, that means, it's flying basically parallel to the ground, or the vehicle orientation is parallel to the ground.
Starliner, this from a camera aboard the ISS, aboard the International Space Station.
All right, we got a good live view here. Sun should be coming up here very soon. You can tell it's a docking port over here because of the way it is, and that's pretty neat. The cone of silence. The RCS is making minute corrections to adjust for that, RJ. Like, as it goes around the Earth, capsule will stay pointed in the same direction. They're using small, minute things with the RCS to keep it nice and parallel as it goes around. ISS does the same thing, but the ISS does the same thing with its gyroscopes. The Z1 truss segment, or Z1 truss segment on the ISS, is a gyroscope that's about the size of a Mack truck. It's about the size of a semi-truck. It's behind the truss segment. You don't really see it that much, but it's freaking huge, and it has a gigantic gyro in it to keep the ISS's revolutions per minute sync to the orbital period. So that's one rotation of the ISS every 90 minutes. So the ISS basically flies parallel with the ground, or at least it appears to. Yeah. You can mimic this in Kerbal, for instance, if you use persistent rotation. You can do the same thing. The ISS is about the size of a football field, Filcher. Yeah, about the size of a football field, or a soccer field, or a football field. They're all the same size anyway. Just everybody likes to call it a different name. Lovely. Soccer. Yeah, soccer field there, dude. All right. Here's Starliner coming in. This shot is on the starboard side of the space station, but this camera is upside down relative to the ISS. It's hanging off the bottom of the truss segment, looking upside down.
Looking real good.
That's the Columbus module over there, the Europeans module.
On the nose of Starliner, you can see that's basically what's pointed at the International Space Station right now.
Sockets are bigger. Yeah, that's why I said about the size.
Starliner maneuvering to keep those sensors pointed at the space station, just as it's been throughout this rendezvous and docking. And
on board.
We're seeing some of the imagery coming from those cameras aboard the Starliner spacecraft.
Very nice. Starliner's about to be Dragon.
That is looking right at the forward port.
See Dragon right there?
The International Space Station is looking at the forward port of the Harmony module. And you can also see the outlines of the GEM, the Japanese experiment module called Kibo, the Columbus European Laboratory, the truss itself, the crew vehicle. So
the crew vehicle.
As Starliner moves in towards the International Space Station.
Yes, yes, the crew vehicle. That's pretty funny. Good evening. I watched Starliner launch live from Kennedy yesterday and got to see your baby Atlantis up close. Nice tech. It's big, isn't it? Yes. The other crew vehicle. Oh, damn.
Houston, Space Ground 2 for Starliner.
You can see the crew vehicle.
I want to let you know that we are not going to do the hold at the 90-meter point. That was designed to get proper lighting, and we are already in a good lighting config, so you can expect Starliner to press into the 10-meter hold point.
The green zone is for loading and unloading. There's no loading
Station copies,
in the green zone.
We're going to bypass the 90-meter hold and continue into the 10-meter hold. And just so you know what we're seeing, we're well within the corridor. and looks like Starliner is starting to converge on the center T in the overlays.
Yes, crew vehicle. We finally meet.
That's a good read, and we copy.
It's pretty funny.
So Starliner is on the move, and it will stay on the move until it gets to the 10-meter hold point. At that point, Starliner will fire its thrusters and pause in its approach, but the lighting is good at the International Space Station.
So what they were basically talking about is they had to figure out if they were getting junk data from Starliner, and that kind of delayed things a little bit. But it delayed it enough to get Starliner so they would do docking operations. While it was light, it would really help, if you could see what you were doing when you actually went to dock the thing, so they could watch the dock, because it gets dark in space when there's a big Earth in the way. It gets really freaking dark. So that because they had to figure out if that data was junk data or not, that actually ended up making the hold that they needed for daylight obsolete, because now they're in daylight. It should really start to get bright in here in probably the next 30 seconds, give or take, if I'm looking at this right. It should get really bright. Right now, the sun is just peeking over the horizon, but there'll be a threshold that you'll see here where it'll be like flipping the light on and off in a room. Turns out the sun is pretty bright when, you can see it.
Again, looking at the view that Starliner sees of the space station.
You're peeking over the horizon.
You can see the Crew Dragon at the top there. Japanese experiment module, European laboratory. You heard me walk through all this just a couple minutes ago, so apologies for the
yes, and the crew vehicle.
But the space station's been up there for 20 years. It deserves to be talked about quite a bit, I'd say.
Based. Okay, something's peeking. Yeah.
We're getting, we mentioned passing that 90-meter hold, which was designed as a way to hold for good lighting conditions.
You said Crew Dragon that time.
Indicated that the lighting conditions now
are
looking good, and in fact, we're inside 90 meters now. We're at about 76 meters from the International Space Station, heading towards
actually a little less than 200 feet, about 180.
Hold. The station itself and Starliner are flying about 270 statute miles over the South Indian Ocean, crossing the Terminator line into an orbital daytime.
Starliner currently just past the 75-meter point, moving in at about 1/10 of a meter per second.
About 200,
again,
230 feet,
10-meter
240 feet.
Hold point.
The other.
Starliner holding its path just as prescribed. It's following in that graphic what you're seeing in the green.
I just want to point out that the desktop,
corridor.
That's not me.
That's basically
that's
the zone
straight up
that Starliner needs to
I have
stay
you guys
in
on
as
full
it
screen.
makes its way to
just
the
in
space
case
station.
anybody's wondering. I just want to make that very clear. Okay? I want to make that very clear. This is them with the desktop. Yeah, see, they got rid of it now. That's right. Check that out. We got a good shot from the ISS on the top of the... I think this is the S2 truss segment here. This is the Japanese experiment module, the Japanese storage module, Kibo, right? And you have the Crew 4 Dragon right here, attached to IDA-3, the IDA-3, and then PMA-3. And then there's an IDA and a PMA, another one of these docking ports here for Starliner. These are the two spacecraft for NASA's Commercial Crew Program, meeting for the first time. Oh, nice, man. That's the crew, the thing. Yeah, why would we need this view? Let's just go to this worst view.
And we're seeing there's that graphic from that you saw just a few minutes ago. That's the view from the International Space Station's monitoring software as it
64 meters out.
Watches Starliner approach. Starliner is
about
63.5 meters away from the
about
space station's
200
forward
feet,
port.
give or take.
We should reach that 10-meter hold point a little bit less than 15 minutes.
Not my mouse cursor.
Starliner continuing its approach.
Thanks, Taz. Well, we signed the PNS and sent it today, so I hope. Thank you. How are you? Someone mentioned the issue with docking in the global chat. They just had some junk data, Van. That's all. Oh, you can see those thrusters firing up there on the top. I saw them for a second. Yeah, Van, they just had some junk data. They had to just verify that it wasn't the right data. It said that Starliner was drifting out of the approach corridor, but it wasn't. They knew that it wasn't because they went and looked through the camera and saw that it wasn't, in fact, doing this. So they confirmed that the data stream was wrong, and now they probably should go figure out why. But Starliner is performing just as expected right now. Everything seems to be good here. I'm okay. I'm actually at my new computer, so I can actually say hello, not just lurk in the shadows. Oh, that's good, Tozzle. Sweet. Well, it's good to see you. And you got gifted a sub. Okay. Is that a 3D printed Starliner? This is actually a 3D printed crew vehicle. I don't have a 3D printed Starliner. I should have probably thought of that. No, it's not 5-head. It's capsule head. .3D printed crew missions. Bad sensors from what I understand. The OMAC thrusters having a little bit of a problem was a bad sensor. So that happens. The bad sensors happen. They proved other ways that the engines were okay, and I don't know if they've reactivated them per se, but
Discovery, go and throttle.
Oh, predominant 10 subs. Here we go. Oh man, sorry for yawning so much, guys. I am goosed. What do you think we're seeing in that lower right-hand corner of the onboard feed?
Getting this imagery coming
Vesta.
in of Starliner approaching the
That's Vesta right there. Vesta is Starliner's onboard optical station relative navigation system. I forget what Vesta stands for. It's some weird acronym.
Go and throttle up.
Long story short, Starliner has cameras and lasers on it, and it's actually the computers on board are actually looking. They're looking for the station. That's what those cameras are. It's one of the sensors looking for the docking port. Like, we had a little bit of a correction from Starliner there. It's looking for the docking port. It's actually really cool. Hokey gifted a sub, and Predominant gifted a sub to Yod. How many people are on the ISS? 7 right now.
Emerged from the darkness of space. As a little more appearing to the crew and the cameras as a little more than a very bright light. Closing
Vision-based electro-optical sensor tracking
getting
assembly.
Very close to the forward port of the space station and really able to show off a lot of the details of the spacecraft as it makes this orbital flight test 2 and as it closes in for the first rendezvous and
Jack will give to the sub to
docking flight path to the space station.
Thanks.
No crew aboard the Starliner on this flight test mission. But it is a human-rated spacecraft, and this.
So that Vesta is a relative navigation system. It's similar to the terrain relative navigation system that Perseverance used. When Perseverance went to land on Mars, its landing ship, the Sky Crane, had a camera and a bunch of sensors pointing downward, and basically that camera was designed to look for a landing site and plot a landing solution in real time, which. That's pretty freaking cool. That's really not easy to do. If you've ever played Kerbal, try landing by just looking at what you're seeing. That is difficult. It is difficult to do. It's even more difficult to do in real life. Starliner's using something like that. Starliner's looking for the station in a very similar way to if somebody was on board and they were looking out the window. Okay, there I am. Okay, we got to go forward a little bit. Okay, we got to go forward. But Starliner's doing it automatically. It's looking for the docking port. It's actually really freaking cool. It's designed to find that docking port autonomously, that's awesome. That's actually a really cool system.
Evening DPC, so we are going to abort the evening DPC. But if you have anything to tell us, let us know.
I don't know what the DPC is, guys.
Okay, copy that. No evening DPC, and I will plan 2350 Zulu.
I'm wondering what's that up there? Every time it fires the thruster,
that's a good read. Once we get to the 10-meter hold point, we will refine that time just a little bit. We'll let you know.
Of course, public.
Okay, copy all.
The funny thing, public, the Boeing commentator said Starliner uses Vesta to know where it is, so it knows where it isn't, which is good. He said that.
So you just heard
I was like, what?
International Space Station Capcom, Rob Hayhurst, communicate up to Bob Hines, who's with Kjell Lindgren. They're both monitoring Starliner's approach to the International Space Station. We're now targeting the second docking window. So the new time of the FAI, the final approach initiation burn, that gets us from the 10-meter hold point into push in for a docking later. That's right now targeted for 6:50 p.m. Central Time.
Savage.
They did mention over the loops that they will be assessing a new contact time, so we'll report that as soon as we get that. A new contact with the International Space Station, but we're no longer aiming for that 6:10 p.m. docking. We'll aim for the next opportunity with that final approach initiation. We're currently targeted for 6:50 p.m. tonight. Starliner looking good though. The rendezvous.
The Vesta. It's looking for parts
flight
of the space
controllers
station,
reporting that
really freaking cool.
Starliner's looking good on its way in. It's now a little less than 35 meters from the International Space Station. Slowing down, we're at about 0.05 meters per second. We're heading towards that 10-meter hold point.
And this does reflect the flexibility built into the timeline, built into this process. The first docking opportunity, it's as they say, it's a target, not a requirement. So there's lots of leeway built into this docking. So it's not really a concern to have this adjustment. Again, Starliner looking great as it hovers out there in front of the forward port of the space station. Currently at a distance, still closing in. Currently at a distance of 31 meters. And
so, fellas, it looks like there's a couple of FOD covers still attached up there. Now, what are FOD covers? Foreign object debris. Those covers are something that's on the ground, that you put on the capsule on the ground. They're supposed to come off during ascent. Like, they're supposed to just rip off from aerodynamic forces. It looks like somebody taped those down a little too hard. What do you tape them down with? Literally painter's tape. Yeah, seriously. They just put, like, plastic sheets over it and differential pressure, because pressure builds up inside of the thruster as you go higher and higher, and ambient pressure goes down, it just rips it off. It looks like two of them are still attached. That's not really too big of a deal. The RCS is still working just fine. It's just interesting that every time Starliner does a correction, it waves at you. The FOD protectors have become FOD themselves. They haven't damaged anything, so. Yeah, here, I'll show you guys. Thomas has a good picture. Here, check out this picture of Starliner. There's the FOD covers.
Starliner inside 30 meters.
See?
Less than 30 meters away from the forward port of the International Space Station.
There's still some of it's still attached.
Continuing to move in at a very slow 0.06.
Wild, wacky, inflatable arm flailing tube man.
That is very much on purpose. When you have two spacecraft moving towards each other, you don't want the two of them to cause any vibrations or anything else. Even in weightlessness, it's important for the research racks on the station that they stay stable.
Service module is jettisonable, Hellfish, and by jettisonable I mean they're getting rid of it, so it's not a problem. But if I worked for Boeing right now, I would be looking at that and saying, okay, that's not a big deal, but it should be very well understood why that thing didn't come off. You really want to figure out why it didn't come off and make sure that doesn't happen again, because little things like that's not a problem, but it could be. It might be later. You don't know. Why roll the dice, right? Don't do that. That would be a dumb thing to do. Don't roll the dice if you don't have to, right? So if I was looking at that, I'd be really wondering why that's still attached. That's supposed to come off, and it didn't come off.
In terms of meters per second and kilometers in distance.
And if it's one thing that I've learned about spaceflight, it's in Kerbal Space Program, you know, if the thing does something you didn't want, you go, huh, well, that's weird. Probably shouldn't have done that. Right? When you say that, what happens? That usually means the rocket didn't work, right? That in real life doesn't happen. That's not a good thing to say, oh wow, I didn't expect it to do that. You don't want to be surprised when you're doing stuff like this. That's not a good thing. You have become the very thing you want to destroy.
And what you're seeing on the screen there, that is what Starliner looks like from 20 meters away in space.
About 60 feet.
Continuing to capture more detail. The closer it moves in, of course, it's going to pause at 10 meters. It's got another 8.5 meters to go on that. And you can see some of the thruster firings there.
Damn. Yeah. Wow, that is a pretty spacecraft, man. It's waving at us.
And what we're seeing on those when those thrusters fire there on the front, those are rain covers. They're put over all the nozzles at launch, so they're just remnants of that. They don't have anything to do with this orbital flight. Doesn't matter that they're there. It wouldn't matter if they weren't there. But what we are seeing there is that Starliner is moving in really well. 15 meters. Again, you can see some of that thruster firing. That's how much detail we're seeing from these ISS cameras.
Sure. Yeah, no, somewhere at Boeing and NASA, they're saying, yeah, why is that stuck on there? And they're like, I don't know. It's like, well, you should probably figure that one out. Yeah, I'm just going to need you to go ahead and come in.
Starliner inside 15 meters.
We had some
from the International
FOD
Space
covers
Station.
get
We're going
stuck.
towards that 10-meter hold point.
And we're going to have to play a little bit of catch-up. All right. All right. Yeah. Hey, Peter. What's happening? Did you submit your FOD cover reports? Oh, great. Someone's getting fired. No, it's a test flight. You don't. If this was happening during operational missions, Noctis, then somebody would have 8 different bosses coming and telling them about it. 8, Bob. So my only motivation is to not get hassled. That and the fear of losing my job. But Bob, that'll only make someone work hard enough just not to get fired.
Rendezvous officer reports that Starliner is in the
one of the FOD covers is still attached to the RCS up on the top, Jackal. You can't see it.
And Starliner is hovering at the 10-meter point, showing...
That's nice!
Station Houston on 2. Starliner is at the 10-meter hold. Perform step 7 in 1.102. And we're working on a finalized FAI as mentioned. And we are seeing really good video from the EHDC.
Okay, station copies. We see the same 10-meter hold. Vehicle mode is hold step 7. We have brought up the 10-meter hold overlay and understand updated time for the initiation of docking is forthcoming.
Good read.
All right, night, drummer. I don't know, Hudster. I haven't seen the back of the spacecraft.
So that transmission up to the ISS crew, advising them that while we do have the FAI initiation, the final approach initiation burn, scheduled for 6:50 p.m. Central Time, the exact contact.
It's automatic.
Time, or the estimated contact time is not still being refined.
3D model doesn't show Dragon. I didn't even notice that, Oki. That's really funny. I'm sorry, that makes me laugh. Savage. Absolutely savage. Dragon is docked to that port right there, but they didn't show it. That's funny. Come on. Oh my god, the crew vehicle. You can see the crew vehicle there. Fred, it's not on purpose, dude. That's not, dude. Putting a Dragon on there is the least of their concerns right now. They're concerned about their own capsule. That's why Dragon's not there. Don't read into it too much, but it's still funny. It still makes me laugh. Last blocks. Flykin, what was your last? Who's in charge of docking up on the ISS? Well, the astronauts on board the ISS are sending commands to Starliner
Houston Space to ground
right now,
2 for
and
Starliner
Houston,
final initiation.
mission control, usually.
Approach initiation time.
Okay.
That time will be 23:53. Latest FAI will be at 0036, and that will be a margin of 43 minutes.
They're gonna hold it there for 40 minutes? Okay. So what's happening? Why are they stopped?
The approach initiation time at 23:53.
23:53. So that's 53 past current hour.
0036, and a 43-minute margin.
Good read.
Oh, nice, Thomas. It's crazy how fast that thing's going. Guys, I'm not exactly sure why they're waiting so long to approach. I think they didn't make the proper time for this approach. But I'll be 100% honest with you. I don't know why they couldn't just send it right now. But I do know enough about spaceflight that you really never just send it. That's not a good idea. Yeah. Just sending it usually ends very, very poorly. So I'm sure they're doing it for a very good reason. Chris B said it's about lighting. Well, seems pretty light out to me. They're in the middle of they're not even close to darkness right now, see? But if Chris B says it, I'm pretty sure he's above suspicion, so that's probably what's going on. The person with the key to the door isn't done pooping. That sounds right to me, Mexican. That sounds right to me. I see no flaw in that logic. I mean, funny story. The tower control on the ISS is not that far from the head. Yeah, they're like maybe 20 feet away from each other. So, I mean, you might be right, dude. I'm not kidding. The toilet's near the point where, like, there's a control station inside of the U.S. Destiny module that is designed for RPOD, Rendezvous Proximity Operations and Docking. The RPOD station is really close to the head. It's close to the toilet. I'm not even kidding. Like, not to like take the joke too literally, but it's actually not that far away. You just shout. The mic will pick it up. Dude, have you ever tried to talk to somebody when you're on the can? That doesn't work. No one can hear you with the fan on. Like it just sounds like.
And now we're up to the International Space Station crew.
That is a sweet photo, though. Yeah, I'm just gonna full screen this one
for Starliner to perform its final approach initiation.
That's pretty cool.
6:53 p.m. Central Time, and it will cross that final 10 meters.
I don't know, Ando. I hate to inform you, but I live in a really small place.
Making contact
so you're on the ISS?
6:57 p.m. Central Time, 7:57 p.m. East Coast Time.
Yeah, absolutely.
Again, plenty of flexibility built into this timeline, but that is the current schedule. No rush. These are all targets, not requirements. And while Starliner pauses right here at this 10-meter hold point, we can.
I noticed that too.
We can really see some spectacular footage of the spacecraft. Again, this is the first time Starliner has been viewed in space from outside the spacecraft. So
Toronto life.
First time we are seeing
Taz, I'll be honest with you. Yeah, the house that Brimo and I are gunning for is not in the city. And, yeah, I'm really happy about that. Oh, it's waving at us. Yeah. So I actually can, like, do this and not touch, like, 3 other people's house. It's pretty sweet. Yeah. Salary, hey, 52-month resub. That's so exciting. Yeah. Well, we don't have the keys yet, so we're getting there. So it's a requirement that the ISS controls any vehicles that's entering its keep-out sphere. They're monitoring it, Flykin. Yeah, they're monitoring it. Think about, like, a plane landing. They're monitoring it, and they can send commands to it because it's remote control right now. But if there were people on board the capsule, people would be the primary controllers of the capsule. Because this is a remote and autonomous docking, they can send commands to it. So, like, if they're looking out and Starliner just suddenly comes towards the station and they don't want it to, they can tell it to stop. So they are in primary control, but Starliner's computers are... Remember, this is a test. They're testing to make sure it can autonomously dock, right? So you got to make sure that works. Forrest Gump waving at Lieutenant Dan. What are you doing here? Is there a pool? Are we invited? You are not invited. There is no pool. When do you think it will be a signed agreement on the new house? Coming weeks, Denny. Probably about a week. Reason for the hold. Okay, Chris is saying something. We sent off the PNS today, Hellfish. Yeah, it's been a stressful day. Long day. Yeah. Holding at 10 meters for optimum lighting, but still knocking on the front door. Wait a minute. So, if the Starliner is this close, does that mean that this camera is the ring camera? Oh, it's waving again. Just doing a little bit of corrections. Starliner's just doing small orbital corrections to do what's called station keeping. They're waiting for optimum lighting. That's per Chris Ferguson, one of Boeing's private astronauts that helped design the spacecraft. So if he says they're waiting for optimal lighting, yep, that's probably right.
Discovery, go at throttle up.
P and S. Yep, P's and Q's. Mm-hmm. I'm sorry, Dave. I'm afraid I can't do that. Open the docking port, chat. Chat, open the pod bay doors. How can there be lighting better than this? I don't know. It is waving, Tozzle, yeah. And Nervous, I noticed that. The soft capture mechanism on Starliner is not open yet. Do you see this? See these pedals right here? There's 3 of them. They're attached to an inner ring, which is right here. They're all attached on an inner ring, and that ring is on springs. When Starliner is going to go to dock, that small ring here, see how there's like 2 distinct colors right here? The small inner ring will extend, and it extends on a they're not hydraulics, I don't think, but it should extend out and with springs. So when Starliner goes to dock, that outer ring will cap the docking port, and Starliner will do what's called a soft capture. Basically, with a soft capture, the soft capture basically gets everything aligned, right? And it hooks in on this inner ring, and then the springs will absorb any differential velocity, and Starliner will just kind of hold there for a second, and then they'll drive the hooks in, and that ring will retract, and it'll bring the main latching hooks. There are 12 of them up to each other, and then the hooks on Starliner will grab the ISS. Now, it's actually interesting to note the ISS docking port has hooks, and so does Starliner. It's not just Starliner's hooks grabbing the ISS. The ISS will grab Starliner as well. If you show us that picture on the front again, I'll show you the latching mechanism. It's actually really cool. The hooks actually go like this. Like, see how the hooks are on one side here? On the ISS's docking port over here, the hooks are on the opposite side, and they're designed to slot into each other and then latch. So they're kind of like this, and they get near each other, and then they hook. They grabs each other. That's called a hard capture. When they have a hard capture, that's when you're good. Soft capture is just basically aligning you and absorbing the shock of Starliner, not shock, it's just absorbing the relative motion of Starliner, and then they'll retract it, and then they'll latch it. That's the hard capture mechanism. Once you have hard capture, you're pretty much good to go. If you look at the left and right side of the docking port, see there's a little panel right here and a little panel right there? Plugs for power and telemetry. So Starliner can tap into the ISS's communication system, power system. It can keep its batteries charged if it needs to. It can basically tap into all the ISS mechanisms. That's what these little plugs are on the sides. If you look, they got a bunch of little things. When that hard capture mechanism, when they start driving the hooks on the hard capture mechanism, those plugs will basically plug themselves into the docking port. It's actually really neat. So right now, guys, they're waiting for optimal lighting conditions. We're about 30 minutes from the optimal lighting conditions here. I'm not going to lie, the conditions are pretty damn good right now, but it's very clear that they want the sunshine for something. If I'm looking at the orbit right, it might dock in the dark, which is, yeah, I don't know why you'd want to do that, but if I'm looking at this right, maybe they're waiting for the sunlight to not be as bad. The reason why is because it's washing out a lot of things. The sun is so bright that you can't really see what any of this does. Now, don't get me wrong, the lighting on this side is cherry, but you ideally want uniform lighting. There is a blue stripe right there. That blue stripe goes all the way around Starliner, and you can't see it. You can't see it over there. The sun is washing it out completely. They're probably waiting to get good uniform lighting. They're literally probably waiting to the equivalent of a golden hour in space. If anybody that knows film knows what I'm talking about. They're probably shooting for the Terminator line right here. That's probably for the optimal lighting conditions. That is, give or take, about 30 minutes away. From here on the ISS's orbit to about here is 45 minutes. So the ISS and Starliner's orbital period is 90 minutes. It's like 91 minutes to do one orbit. So half of that's at night, half of that's during the day. So you get a sunrise every 45 minutes and a sunset every 45 minutes. Sunrise, 45, sunset, darkness for 45, sunrise, sunset, etc., etc. So they're currently targeting 53 past to resume docking operations. So they're probably waiting for the Terminator. They're waiting for a nice golden hour lighting so they can really get a good visual on what's going on. Because part of it isn't just looking at the telemetry. Part of it is actually watching physically what the vehicle is doing, like with these cameras. That's why they have high-def cameras right next to the docking port, so they can watch everything working. It's actually super useful. Just press H, yeah, right. You maybe could see the ISS pass over. Let me look at the. Oh. That's right. I'm just going to go see if it's cloudy out. I will be right back. Yeah.
For other
it might still be too bright. It most likely is. But I'm just going to go take a look. It's not over me right now, but it will be in about 10 minutes.
Brought along with it cargo and resupply for the crew. Soyuz MS-21 brought up 3 of the Roscosmos cosmonauts now living on the space station. Progress 79 and Progress 80 are 2 Russian vehicles that also brought up resupplies for the space station.
Space Ground 2 for Starliner.
Go ahead.
Hey, Bob. Just want to let you know that we are seeing all sensors working great. The hold looks really good, and performance is really good. We appreciate you continuing to watch it.
Okay, sounds great. Yeah, we're monitoring. It looks really good, right? As it starts approaching a boundary, it reverses direction and seems to be station keeping really well.
Concur.
Again, those voices you're hearing from the International Space Station belong to NASA astronaut Bob Hines, who is on his first mission to space, and Kjell Lindgren. There are 7 people living on the space station, and it's currently about 11:23 p.m. GMT, which is the time zone that the space station uses. They will be getting ready to go to sleep. However, since we have shifted the docking time of Starliner, we'll still have Lindgren and Hines monitoring its approach and arrival.
It's cloudy out. Emotional damage. Strimmerman yells at clouds. Does the crew go through the smaller circle or the bigger circle? This whole thing is the hatch. Just inside of the inner ring. Soft capture mechanism. That's all hatch in there. Also, yes. Well, actually, it's basically right here. It's hard to tell. Hey, nice flaps. Forlorn, it's waving at you. Yeah, some of the FOD covers didn't come off. There was covers that were taped over the thrusters so like it doesn't rain and water doesn't pool in the thruster, because that would be bad. You don't want to hydrolock your rocket engine. That probably not a good idea. But it looks like some of the FOD covers have become FOD themselves. You are the chosen one! You're supposed to fend off the debris, not join it! The Starliner have a front window in there, yes. Unfortunately, I ain't gonna see a blooming thing because it's cloudy here. Yep, it's cloudy here too, Ice Mage. Yep. The Starliner have a front window. Yeah, I already answered that. Front window and then a commander window so you can look out. It's only one window though. And then there's a hatch window as well. I hate you! Do you think for the next mission Boeing will install a camera or two? There's cameras on board, Axiom. I think they're more focused on making sure they get the mission right than, like cameras for us to see. The Vesta cameras are working. Yeah, overachieving FOD covers.
Just a reminder, if you're watching live and you have a Twitter account, you can ask us your questions with the hashtag AskNASA.
Twitter?
This one comes from Tiffany, who wants to know what time the hatch will be open tomorrow. Our hatch coverage, our coverage of the hatch opening will begin at 11:30 a.m. Eastern Time tomorrow, and we expect to see the hatch opening around 11:45 a.m. Eastern. We'll also have some welcome remarks by the crew on board, so make sure you tune in here on NASA TV.
Stage 5 Klinger wrecked. That was supposed to be bowling pins falling over. Okay, so once again, they're holding right now for optimum lighting conditions. It seems like it's too bright. The sun is washing out some of the cameras. They're just gonna wait till the sun goes down a little bit. Fortunately, that's not very long. It's about 30 minutes from now. So
International Space Station and Boeing flying just 10 meters apart from each other.
Right now, Starliner's just kind of station keeping. It's just kind of chilling.
About 260 miles over Mexico.
Station keeping and chill. But it's gonna dock.
Again, we are in a hold
Don't
point.
make that face.
No,
where are you going? No, come back.
And we expect to see that resume around 6:53 p.m. Central Time or 7:53 p.m. Eastern Time. That's constantly under review. We want to make sure that the station has good signal with the ground and with Starliner, so that time may change, but we're looking for that target time.
Space Ground 2 for update to planned FAI.
Final approach initiation, FAI.
Go ahead.
Farmer, the planned FAI time will be 23:57. That will get us past a TDRS handover and ensure good solid comm.
Okay, copy that. New FAA time of 2357. Thanks.
57 past the hour, guys. It's about 29 minutes out.
And just as I was mentioning, the final approach initiation will begin at a now shifted time of 23:57 GMT, the time used aboard the International Space Station.
They're waiting for a TDRS handover, which means that they're going to go over the hill, like they're going to go out of range of one of the tracking satellites that NASA has in geosynchronous.
So we're less than 30 minutes away from that.
And it'll hand over to another one. There's 3 sets of satellites that are triangulated around Earth. If you put Earth at the center, NASA's communication satellites are in geosync. So what's geosynchronous? Geosynchronous is a satellite where it takes 1 day to do an orbit. It takes 24 hours to do one revolution. So the satellite appears to hover over a spot on the Earth, right? NASA has 3 sets of them that are every 60 degrees. If you're looking like down at Earth, they're every 60 degrees, or no, every 120 degrees, and there's 3 sets of them. But if the space station goes over the hill and goes out of range of one TDRS, tracking data and relay satellite, if it goes out of range on one, they have to switch it over to the other. It takes a second to do that, and there's a momentary communications blackout for them to reroute the signal. You gotta remember, like, it's like, what do you mean, oh, it takes a second? Yeah, I mean, it's going to a satellite that's 23,000 miles that way, and then coming back down, and then being relayed around the Earth. And the handover probably takes like a couple seconds. Not bad considering, pinging a satellite that far away. That's pretty good. So they're gonna wait for the TDRS handover. You'll know when TDRS handovers happen, guys, because the screen will go blue for a second. But that was a really nice shot. It looks like the lighting conditions are getting better. We can actually see a lot of Starliner here.
Coming up on the timing adjustment, as we've mentioned, there's a lot of flexibility in this
see
timeline.
Like it's getting better. It's too washed out. They wanted to make sure they got a good shot.
Radioing
That's
the
fair.
crew of the ISS that we are looking at.
That's Water on Mars series. Yeah, it's pretty good.
Final approach initiation burn at 6:57 p.m. Central Time, 7:57 p.m. Eastern Time. That's gonna put us at a docking time of 7:01 p.m. Central Time, 8:01 p.m. Eastern. So,
yep, that's right, Andrew. You gotta take your time.
Hold point that
don't,
you see there
don't
on
screw
your screen.
around. Make sure you do it right.
It'll take 4 minutes.
Optimal lighting conditions
Starliner
are part of risk
that.
mitigation.
Space Ground 2 for timeline updates.
It's easier to dock when you can see the damn thing. That's what I'm trying to tell you. It's true. Bruh. Yep. There's the plugs, a little bit garbled.
Yeah, I just wanted to point out the Node 2 entry activity, the no exercise activity, and the maneuver after docking. They will, of course, shift with the new
beautiful docking port and thrusters. Yep. Okay, Same thing happened with Dragon's first docking, from what I recall. Bingo. Yep, DM1. Oh yeah, we were here for that, dude. I covered that too. I've covered almost every single docking to the ISS in the last like 5 years.
They of course, this is not the only thing on their timeline, and during the docking operations, during dynamic operations, they try to minimize vibrations on the International Space Station environment as much as possible, to make sure that the docking of Starliner to the station is as smooth as possible. So there is a constraint on their timeline on when the crew members inside the International Space Station can exercise. Of course, Lindgren and Hines are very busy with the monitoring operations. They're taking a look, and they have reported that the Starliner is doing a very good job at station keeping, meaning staying really and holding at that 10-meter hold point. But the rest of the crew members on board are in a pre-sleep or sleep period, and they have the ability to exercise if required.
And CST pre-pack.
It's Nomex, guys. That's what that cloth stuff. This cloth stuff that's on
Jessica,
Starliner.
We estimate
Nomex.
you have about 45 minutes left of CST pre-pack. The good news is we are going to schedule you a block tomorrow to finish that up so you can enjoy the rest of the rendezvous and dock.
Pre-sleep period, Gav? That's basically free time. Free time. That's NASA's way of saying you're not on the clock. Yeah. Pre-sleep. They would
I
call.
copy
They would
that
call it
there's
that.
about 45 minutes left. The only remaining steps that I'm tracking are just the step 9 at the end that involves going into GEM and Columbus, which are obviously closed up at this moment.
Ugh, that's pretty bad. Cool thread.
Okay, that is good info. Thank you, Jessica.
Oh, nice, Novus. Yeah, that's pretty awesome. Yeah, Novus, look down in that thread. Yeah, see the pressure differences? That's unbelievable that little arrow skirt changes all of that.
And we have another question that's come in from Ask NASA, from Richard. It appears there are 2 objects at the top doghouse that wave back and forth from time to time. What are those? We've been getting this question a lot, so let's take that on. It is really simple. They're rain covers that are over each thruster.
Right,
when
Blue?
the rocket is there at the launch pad, we put those covers over them, and it protects them. And as soon as most of them fall away during ascent, during just the aerodynamic forces. So it is that's what normally happens. In this case, the covers stuck around a little bit longer to make this trip. So the fluttering that you're seeing is caused by the thrusters firing. They are very small thrusters, and they're just performing little maintenance burns, we call them, basically keeping Starliner in its position in this 10-meter hover. So little thin sheets of plastic, keeping everything together as it heads out. And
nice, 12, that's cool.
That's all there is to that story, I guess.
I like this guy.
5.04 and 6.04.
Yeah, see these things? Some of it didn't come off all the way.
A mix of bubble wrap, foam.
So as we're looking at Starliner hovering here at the 10-meter hold point.
Okay, copy. That helps a lot, thanks.
We are seeing the graphic and the representation there as Starliner continues to hold. So a quick recap on our expected times coming up for final approach initiation. That's going to start at 6:57 p.m. Central Time. And then...
Yeah, Andrew, me too. They called it Dragon.
Will move ahead at a very steady, very deliberate pace. And go those last 10 meters to the forward port of the International Space Station.
Yeah, she's holding right now.
With a contact time of 7:01 p.m. Central Time, 8:01 Eastern Time. That adjustment was made because it gives the spacecraft and the space station, gets them a little bit past the point of what is called a TDRS handover. The spacecraft communicate with the ground through NASA's TDRS system, telemetry and data relay satellite system. And there's basically a series of communication satellites in geosynchronous orbit, more than 22,000 miles above Earth.
Did I just say this?
They relay, just like their name implies, they relay data.
Angle, Firefox.
From the spacecraft in
there
Earth
are pedals
orbit
on the docking port
down
that
to the
will
ground.
align.
So in order to have the Starliner and International Space Station on a good lock there with the TDRS.
Anyone working on an automated docking and pressurization system so all this hand-holding isn't needed? Starliner has that. Not station pressurization, though. But Starliner has its own optical station relative navigation system built into it called Vesta. It found the space station by itself. True story. Yeah. Yeah. It has a very, very advanced relative navigation system. And the crew has been pretty hands-off of it for the most part, Hellfish. Hand-holding, though. Like, I mean... Yeah. The reason why they're going slow here is because it's a test flight. You don't want to just send it. And they're waiting on optimal lighting conditions, so I'm not really sure what you mean by hand-holding. I mean... an entirely automated system? This is pretty much like 90% automated already. Like, I'm pretty sure they don't pressurize the vestibule because it's attached to the ISS, which is old. If I had to guess, I mean... What's that, Bradley? I can't help but see the Death Star laser. Scott's a nerd. I mean that in a very endearing way, guys, so don't read too much into it. I know that. I know Scott. He's a good dude. Hard-working mother trucker.
As the International Space Station and Starliner fly over the Earth, they hand over the communications between some of the tracking and data relay satellites that provide some of the video that
if I called Scott a nerd, he'd probably
from
say
low
thank
Earth
you.
orbit. Right now we are in a handover period, so we'll be regaining some of those views from the cameras outside of the International Space Station here very shortly. In the meantime, the Starliner continuing to hold at that 10-meter point.
Sorry for that so much,
waiting
guys.
for good lighting conditions, an evaluation, and a go to proceed for docking.
Oh, man.
Right now we're targeting contact with the International Space Station shortly after 7 p.m.
Those are really... Some of those are really old
And that
pictures.
7 p.m. is Central Time.
Jeez. Yep. Yep, that's me. Starliner drifted out of his cone. Is that okay? Yeah, it's fine. We don't make the corrections here. Pics from the good old days. Some of those pictures are like almost a decade old, Shex. That's crazy. Maybe in the new house you'll be able to sleep better. That's what I'm hoping for. That's what I'm hoping for. You struggle to sleep all my life. The struggle.
All right, as we continue to hold here for the next few minutes up until that FAI, that final approach initiation, that's the burn that's going to push us in for a docking, we'll continue to monitor hashtag AskNASA for additional questions. So keep sending them in. We're getting a lot of good ones to help us understand the Starliner story on OFT-2, Orbital Flight Test 2. This next one's from Jordan, who's asking mostly about the docked phase. What else will the Starliner do while attached to the International Space Station? Well, being that this is a flight test, really this is the first flight of the Starliner to the International Space Station, but it is a test through and through. We've been seeing a lot of demonstrations of the Starliner's capabilities up through this point. We've seen commanded holds, we've seen a test of some of the abort engines, a test of it being able to maintain attitude in a hold position, testing of the Vesta system and space-to-space commanding, the whole lot. But the testing does not stop once it's docked to the International Space Station. The flight control teams will continue to check out its connection with the International Space Station, verifying good communication, data, power paths as it makes umbilical mating to draw power and connect some of those communications. They'll be testing out the various systems, including its quiescent phase, what it will be like when it's docked for long periods of times, as its main objective is for long-duration crew missions to bring crews up to the International Space Station. There's also about 500 pounds of NASA cargo and 300 pounds of Boeing cargo inside. They'll be able to take some of those goodies and bring them inside the International Space Station. Starliner will also be bringing some equipment home, including some nitrogen oxygen recharge system tanks for refurbishment so they can be reflown at a later time. So the crew, the Starliner is expected to be docked to station for a minimum of 5 days to allow proper testing, to allow cargo transfer, enough time for all of those items to be executed before it undocks and returns to Earth. Very good questions. Keep sending them in using the hashtag AskNASA.
Talking to my dad. He's my freaking dad's talking to me. Hi, Dad. He's like that thing's docking with cameras and lasers. I'm like, yeah, it's pretty freaking cool, right? Yeah, I guess. Yeah, I guess we're definitely related. I thought that was freaking sick, right? So I want to say this again. I just want just to bring it up. Starliner has cameras and lasers on it. Like lasers. No, it has a camera and a laser range-finding system called Vesta. And Starliner is looking for the space station. When it was coming up to the space station, it was looking for it. The cameras were actually looking for the station. Now, when you think about that, you say, "Oh, the cameras are looking for the station." It's like it's a computer. Of course, it sees the station, right? No. The cameras are looking for it, and the cameras, using software, identified the station, and it came up with a docking solution. Like Vesta is a form of what's called a relative navigation system. So basically, think about it. Think about the computer. The computer's running Starliner like there's like a person would be. Like if there was a person inside of it, they'd be looking out the window and being like, okay, where am I? Okay, I got to do a little bit of a burn here. Okay, where am I? Okay, got to do a little bit of a burn here. But it's doing it automatically. That's really, really freaking cool, actually. That's like my favorite part of this thing. I didn't know about that. Saber, these are some neat graphics. Yeah, it's like KSP2. It do be looking good though. Thanks for the raid, man. How you doing? What computer is it on? Windows 97? It's on Windows Geary 7, actually, public. Have you ever heard of the Gear Wars? I don't envy you. Look at that thing. Look at that. There's the plugs that I was talking about. That's how they tap into station power and station communications. I don't know if one's power and one's communications. I don't know the exact thing, but these are space plugs. So when the docking port hooks go to latch into each other, there's hooks on the ISS and there's hooks on Starliner. When they go to latch in, and they drive the hooks in, and it brings it together to make the seal. The plugs they plug into the station, just like you put a plug in a freaking outlet. It's the same thing, only it's a space version of it. And space makes everything cooler. It also is very cold in space because vacuum. It's actually not cold; it's vacuum. Different, but kind of. Oh, I envy you. I'm good. How are things going here? Saber, everything's going here. They're holding for optimum lighting conditions and a tedious handover. We should be coming up on final FAI. The FAI is the final approach initiation. It's dark. It's dark! I could fall into a precipice. They're working on FAI here in about 10 minutes. We should see the docking procedure start. Starliner has been holding about 30 feet off the space station, about 10 meters, 33 feet, 10 meters off the space station. Impossible. No ship that small has a cloaking device. Sir, the Starliner no longer appears on our scopes. Sorry. I think that's a different type of space. Anyway, so they've been holding. They're waiting for optimal lighting conditions, I guess now. And they're waiting for a tedious handover. Right now, the ISS is about 420 kilometers up, going about 27,600 kilometers an hour, and it is currently over northern France. It's flying over Normandy right now. Yeah, nighttime over there for the Euro guys. Dark lighter. Biggs dark lighter? You underestimate my power. I'm not sure, Axiom. Yeah, TJ, it's funny because Boeing's... Okay, you want to hear something weird? SpaceX's capsule uses LiDAR, all right? It uses a LiDAR system, and then it uses it has basically an antenna on the ISS that it's looking for, and it uses that in LiDAR to find the antenna and find the docking port. It's funny because that's SpaceX's, right? So, you know, SpaceX, Tesla, owned by the same guy. Tesla Autopilot does not use LiDAR. It uses cameras and lasers for the full self-driving cars, right? The funny thing here is that Starliner's relative navigation docking system works more like Tesla Autopilot, and it works more like Tesla Autopilot than the SpaceX capsule does. That's very strange. I never really realized that. That's weird. TJ, you reminded me when you said it's like a self-driving car. It is like a self-driving car. That's how Tesla's Autopilot works. It works exactly like that. The ISS has infrared cameras. It has all kinds of cameras on it, Ilya. Yeah. Squish, what's up, man? So Starliner is getting to work out its station keeping abilities right now. Do we see occasional thruster firings? Yep. You can actually see the thruster firings work over here. Yeah. It's pretty freaking cool. Yeah, you can see if there's any deviation, and these numbers will go to 0.1 when they're doing small station adjusts. Starliner is trying to stay right dead center of the Death Star laser right here. See that? To quote Scott Manley, Scott called it, he's like, I can't unsee it. It looks like a Death Star laser, right? It's trying to stay in this. This cone, okay, this cone right here is called the approach corridor. It's basically the runway. Or, well, let's not say the runway. Let's say the glide slope, okay? That's the glide slope for Starliner, and it's in a hold, just like a plane would be holding to land on a runway. Same idea. Obviously, it gets more precise. The closer you get to the docking port, you got to be pretty precise to get near that. You can see how much it's drifting in the top right. Yeah, you can see that there are perturbing forces on Starliner there, and it's just kind of, it flew in here, and it's just kind of holding there. It's just kind of flying in formation with the ISS until they give it the go to final dock. That's called FAI, Final Approach Initiation. Docking 24 times? No. Last. The two plugs do exactly the same thing. They are both for power and data. There's two for redundancy. Good to know, Thomas. Yep. I hear a lot of people saying Teslas cost so much, etc., etc. Then I slowly bring up the price of a Tesla. It's like $30K and like your $130K top heavy death trap. I'm not sure how that has bearing on the conversation, man, but I mean, sure. Sure. Okay, so we're about 5 minutes out from FAI. Once again, that's final approach initiation. Once they give the go for FAI, that means this thing's gonna send it. Well, not like that. It's not a full send. It's just they shipped it via ground, not via airmail, okay? But it is shut up. The analogy is funny, okay? You laughed. I got a smirk. Don't lie. So they're gonna give it the command to proceed for final approach here in probably about 5 minutes. Yeah, it's just a nice gentle half send. All right, half send. It's like you don't want to beat the devil out of it. You don't want to. But just a little bit, All right, chums, let's do this. Leroy Jenkins! That's how people get hurt in spaceflight. Unlike the last big module, Starliner is not going to flip the station. Ooh, cringe. It's cringe. Oh my gosh, he just ran in. God, stick to the plan, chums. That's still funny, guys. Sorry, I dated myself with that meme. I dated myself hard with that meme. I understood that reference. Not so much with that one. Oh no, cringe. Yeah, right. Yeah, Wefro, right? It's funny you mention airmail because the Boeing paint job looks like airmail stripes. Yeah, it kind of does. Don't you date yourself often? Yeah, I'm a victim.
Houston Space Ground 2 for docking status.
I'm a victim of circumstance. Repeating, of course.
Farmer, I wanted to let you know that a few of the NDS components did not go to the an intended config. Therefore, we need to retract the docking ring to reset the system. We're expecting that to take about 30 minutes. We will come back to you with a new FAI time.
Copy that. 30 minutes to retract the ring and then re-extend it. And just confirm we're happy holding at 10 meters while we do all the troubleshooting.
Okay. So the soft capture. The ISS is gone. So the soft capture mechanism did not extend, right? From what I heard there. Soft capture mechanism is a little docking ring that extends out.
International Space Station, Capcom, Rob Hayhurst communicating up to NASA astronaut Bob Hines. He's with Joe Lindgren. They're inside the International Space Station right now, monitoring Starliner as it holds at the 10-meter point. The NASA docking system, the NDS, retracted its ring fully. They were checking out some of the systems, but there are some that still need to be verified. So the teams here, after some discussion, elected to retract the ring. They're going to go ahead and pull that back in and then reset the system to try again. That process is expected to take 30 minutes.
ISS crew is ready for final approach monitoring and capture review is complete.
Houston copies. Thanks for the words.
So they're literally turning the docking port on and turning it off again. Power cycling.
And the space station crew, of course,
it's true.
Sticking with it, making sure that they are
try jiggling the handle.
Task of monitoring Starliner's approach. The Starliner, again, is holding at 10 meters. They're planning on retracting the NASA docking system ring to reset the system, and that is expected to take up to 30 minutes.
Please hold.
The back end of the flight final approach initiation window is expected to be on sort of the
pretty good
assessment time.
It's not using
so we'll be targeting a new window. We'll assess the next opportunity to push in for a docking, making sure that Starliner and its systems are all good before we press in for that docking.
It'll be fine.
And we'll get back to report that as soon as we have more information on the new window time.
They do, Liam. Yeah. I'm telling you guys, I always say we get spoiled by SpaceX, man. They make it look so easy. This stuff is not easy. This isn't a mark against Boeing. This is hard to do, man. This is really freaking difficult. Like, you got to keep it all in perspective. You don't know how difficult that is. It's very, very tough. And once again, SpaceX makes it look so easy. And that's a testament to their hard work. I mean, it's not that these guys aren't doing hard work either. This stuff takes time.
Flight controllers reporting
it's tough.
That the
we just
ring
get spoiled by how much SpaceX
retracting.
Launches. Here's the video
As you heard
enjoy.
there on the call to the station.
Already,
this is a.
Is that the 4K?
This is a step that'll take about 30 minutes. So they're assessing the.
Would it help if I got it pushed?
New times.
It might.
Final approach initiation and contact.
Yeah, no, we got a docking ring, not a reactor leaking. You got a reactor leak up here, very dangerous. Just give us a few minutes to lock it down. And who is this? What's your operating number? Boring conversation, anyway. But yeah, this stuff's difficult, man. If the docking ring is the only thing that's giving him crap now, that's like 98% of the stuff right. So just bear with us. Be patient. Not with us. I ain't them. Bear with them. We'll get there. We'll get there. Look, we're gonna have company. Boeing conversation anyway. Wait, what? Maz, yeah, everything's fine here. How are you? Who is this? What's your operating number? TK421, why aren't you at your post? Sorry, I don't want to do too much quotes from that. I don't want to get sued. Fire a grapple hook. Reel it in. It's like going fishing. You know. You sent me some things? Did you send me some things? That monitor is currently being taken up by stuff. Alright. De Madure Festival. Oh. Yes. Yes. Yes, Mutter. Very, very good. Very good find. Very nice. Very nice. Very nice. Let's see if we can bring some of this stuff up here. Oh, looks like... Oh, we're playing B-roll. Here, check this out. Let's look into it, Mutter. Let's see what we can see here. Alright, so here's the docking system, guys. So if like, can you see this kind of inner ring right there? That's the hatch. Well, the hatch is kind of down there a little ways, but there's your drive hooks right there. Right? One of the drive hook has two sides. One of them is passive and one of them's active, and they kind of latch into each other, right? These docking pedals are part of the soft capture mechanism. If you note, see the soft capture mechanism has these coils down there. They have the coils on that soft capture mechanism, so yeah, see, there we go. Well, that's APAS. That's the port that this is derived from. But you see how that inner ring can extend? This is the ring that they're talking about. It looks like they extended it and retracted it, and they extended it again, and they saw something that they didn't like. It was something with the NDS, from what I can tell. And yeah, there's a CAD picture of it. But basically, these are retractable springs, and it'll absorb the docking force in the docking port when it goes for soft capture. But they did something. They saw something with the mechanism that didn't like. They said they saw something with the NDS, the NASA docking system, and they said they're going to retract the NDS and put it extend it and retract it, or retract it and extend it again. Basically, the equivalent of arming and de-arming the docking port. See this green part? Those green parts are designed to move forward. It's designed to be extended to look like that. See it right there? That's Apollo Soyuz. That's pretty cool. Yeah, see this part with the pedals, that extends out, but it seems like the NDS did something that they didn't like. So they said they're going to find a new T0 for FAI, final approach initiation, and then promptly cut to B-roll footage. Oh, they're back. Just have one of the astronauts go out and wrangle it into place.
For those just tuning in, the Starliner is holding at 10 meters. The teams have decided to retract the NASA docking system. The ring that was extended is now retracted to allow them to reset the
pedals
system.
Are fixed to the ring,
are looking at
they're
the
just used for
docking system. Teams are now evaluating the next opportunity to push in for docking.
Something's going weird with the docking port, bro.
We expect to be
exactly
reporting that soon.
Once again, Starliner is just doing some station keeping maneuvers. It has plenty of fuel. Even though this animation looks like they're shooting out a lot of thrust, these are the low Z thrusters, so the fine control thrusters. They're not using that much fuel. Each one of these maybe uses a drop of fuel every time it fires. You don't need much to keep it just on an even keel, so to speak. So if Starliner can station keep there indefinitely for a very long time. It's not really that big of an issue. Sometimes you just gotta lick the stamp and dock very slowly and professionally. Yep. How long is the docking window? I mean, Bobby, they could sit there for a pretty good amount of time. Ideally, you want to, if I'm understanding it right, they want to wait so they can actually physically be able to see the thing docked. They want to wait till the sun's up. But you got to remember, in the middle of the day, so to speak, when you're up there, without the atmosphere to diffuse it, stuff gets really, really, really bright. Approximately 4 days. There you go. Yep. Yeah, if like in there, it's just, yeah, it's a, like a, this is very, 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 very low energy thrust. There's a couple of reasons for that. One, you want to make more minute adjustments, right? You don't want to use a big rocket engine when you're that close to the space station because you could hit something. Second part of it is that this spacecraft is shooting out gas. It's shooting out gas at a really high velocity. There are things on the ISS, the solar panels, that are pretty delicate. And if the solar panels catch some of that gas, right?
Station Houston, Space Ground 2 for FAI time.
It can put unnecessary load on the truss segment. That was studied during the shuttle program. You don't want to do that. You need to use the little baby thrusters when you're close.
We've been able to extend out the latest FAI time for this opportunity to 0042, which is about 37 minutes from now. We do expect that the NDS system is going to be in a good config prior to that. So
solar panels are on the back of the service
module. A little
bit
before we initiate the approach, but we do expect to make this window.
Okay.
Okay, that sounds great. So FAI time stretched out to 0042. So within 37 minutes, we can expect to start approach.
I'd have a piece of paper. The solar panels need to be light. Remember, they need to be light. That's a big solar panel.
Okay,
They're about as delicate as a piece of paper. Yeah. Yeah, if like, and they had damage on a solar panel one time. It ripped a little bit, and then.
So you heard their words up to the crew.
The solar panel ripped one time, and they sent an astronaut, Scott Perzinski, out there, and he
Discovery, go at throttle up.
Did some knitting in space and knitted the solar panel back together on STS-120. It was a pretty legendary mission. It's really cool. There are some insane shots of Scott Perzinski out on the end of Canadarm2, like at the bottom of the solar panel. Yeah, it's a hardcore mission. Here, I'll show you. Like, you'll see the shot and you'll be like, damn. Yeah, here we go. Here's the picture. Look at this. That's a long way away. Yeah, isn't that nuts? See? You gotta sew it back together. It's still sewed back together, man. Isn't that crazy? Now that was a ballsy mission. I remember reading about this. I'm like, wait, he did what? Yeah, it's Scott Perzinski out there hanging out the end. He's a NASA astronaut. It's really, really freaking cool. Some of these shots from this whole thing are just like, wait, you did what? Yeah, you went out there and just sewed it back together. Like, what else are you gonna do? It's like cloth almost. Just sew it back together. It'll be fine. Yeah, look at this. Okay. Yeah, Flacken, that's a dangerous mission. Nobody goes out here on the solar panels. You really not. Like, they made it so the arm could reach out there, but just in case something like this happened, but you don't really Yeah. It's the only time it's ever happened, thankfully. Like, it's ridiculous. Last time, actually, astronauts were out there, they out that far on the space station was actually pretty recently, now that I'm thinking about it. They don't go out there very much, but the last time they were out there was when they installed the IROSA solar panels. They have upgraded solar panels for the ISS that they installed in front of the current ones. They were actually made by Boeing, and they were brought up by SpaceX in the trunk of a Dragon. And the arm grabbed the solar panel out and then attached it. And they were astronauts were out there attaching the IROSA solar panels. Yeah, International Space Station, Rollout Solar Array, IROSA. I'm good, human. How are you? Yeah, Nuggets, of course. It's just paper, though. It's paper rocket. I was talking with a guy that worked on the Canadarm simulation. He said the most stressful day of his job was the day they had to figure out how to get the astronaut out to the solar panel array. Yeah, Saber, that's really getting to the end of the arm's reach, for real. That is... It's not really designed to go that far. That's why that mission was nuts. That's right, T-Man. Yeah, they're Moore's rollout solar panels, yep. The Air Force will be battling... The Air Force has a Halo team? That's all. The Space Force has a Halo team. God, that makes me happy. That's one of those things where I'm like, yep, that makes perfect sense. Wasn't there also Salyut in Progress solar panel collision? That was on Mir, Swishin. Wrong station. Not gonna lie, yeah, Thomas, like, of course, yeah, like, why wouldn't the space, like, if the Space Force didn't have Airmen and Guardians representing the U.S. Air Force and Space Force Gaming League attended the rollout of OFT-2. If the Space Force didn't have a professional Halo team, I'd be really concerned. The Space Force gaming jersey? Wait, what? That's a thing? Oh, that's awesome! Yes! Yes! I love it. That's so cool. That's so good. So funny, dude. I love it. Dude, I want one. Where can we get those? Can we get those? Halo the game or Jumpers? Like the video game, they have a Halo team. How does one acquire one of those? I want one of those. That's awesome. Well, they probably have that too, Arctic. But I think high altitude, low parachute opening is Army or special. It's USS, United States Special Forces. Special Operations Command, I think, is what it's called. I think. I don't know my stuff. I don't know that too well. Yeah, well, whatever, dude. Whatever. So after 37 minutes is the mission. No, it's just the attempts for the day, and if they can't get good conditions for docking today, they'll back Starliner off and they'll just put it in a parking orbit behind the ISS, and you'll just try another day. Oh yeah, Everest? Oh, sweet. There you go. Yeah, Special Operations Command. SOCOM. So once again, NASA and Boeing are seeing some behavior on the NDS.
Getting a look at the
NASA's docking
flight
system.
Director Ed Van Cise. To his right is the Starliner Capcoms. They're here to learn about the processes and
they're having some trouble with the docking
decision making that's happening.
They tried shutting it off and
so
turning it back on.
Can relay it to future crews on board Starliner. You have Neil Magata there, as well as Butch Wilmore, who will be inside the Starliner vehicle for the crewed flight test. To Van Cise's left is Pooja Jasrani, another flight director here, also monitoring Starliner systems.
It's just an orbit where you park behind, like it's usually an initial insertion orbit.
They are actively discussing some of the next steps and making sure that we're good to go. We're targeting the end of this docking window opportunity. So the final approach initiation.
No, flight director's right here.
Burn,
sorry.
We're currently targeting
that's the flight director.
7:42
Capsule commander is right there.
p.m. Central Time. That'll push us in for a docking.
You know, because it says flight director on his desk. with a really cool sign. It's backwards for us right now. It says yeah, see, that's flight director right there. Capsule commander right there. It's just backwards, though. It's actually accurate with the Apollo 13 movie. Well, this is Starliner's control room. This is a shuttle. This is a former shuttle control room, which, yeah, and that can trace its roots right back to the Apollo program, which is really cool. The positions don't change. They thought about that and thought about it in the positions to keep them in the right spot. Hello?
Hi. I look funny, chat, so forgive me. But I forgot to tell you earlier. Guess what happened today after we signed the PNS?
Oh, no.
The other house went back on the market.
Whatever.
But a realtor called me and was like, hey, so what do you want me to tell this guy?
Oh, the other guy?
Yeah.
That was the summer car house?
Yeah.
Tell him to freaking pound sand. You screwed up, man. That ain't my problem. We found a better house anyway. We found a way better house than the summer car house, so whatever.
That's all. I just meant to tell you that.
No, that was funny.
P&S, mutter.
And rendezvous officer
Get your
just
head out of the
reported
gutter.
to flight
Purchasing
director that,
and
Demo 3,
Purchase
which is
and
a series
sale.
of Vesta demonstrations, have been completed.
Told him to pound sand. Freaking.
So while Starliner holds here at the
The first house that we offered, that we put in an offer on, they rejected our offer and said no, and we could get more money, and then put the house on the market, and then when they put the house on the market, the realtor realized that they didn't have all their paperwork set. There was something with a lien on the house or something, or it went into what's called probate. So probate means that they don't know who owns the house, like on paper, and they have to figure that out, which is, oh, that's all kinds of red flags. So we said, yeah, we'll go look for another house. Bye. Yeah, that was the first house. Yeah, now it's back on the market, and it's funny. The guy called the realtor. It's like, no, we're good. Yeah, we dodged a bullet. Yep. Yeah, we really did. I'm like, wow, that sucks for you, man. Dodged a bullet there. Yep. Yep. That could have ended very poorly. Yep, that could have sucked. Oh, dude, look.
Station Houston, Space Ground 2 for Starliner status.
See the thrusters firing? All right, here, hold up. I'm going to shut up for a second.
1-2.
Good news, the NDS troubleshooting was successful. The ground is in the process of re-extending the ring. We are expecting to make this window.
Okay, docking ring is working correctly now. That's the ring on the front right here on the
That's great news. We're standing by.
NDS, NASA's docking system. Starliner and Dragon both have the same docking port, and they were just having some weird
going up to the crew that the
weird info coming from
docking
it, but they
ring
fixed
troubleshooting has succeeded.
They literally extended and retracted the docking port, and that fixed it. Hey, sometimes that happens. Mission Control is the original IT department, guys. Just saying.
Aviation burn at 7:42 p.m. Central Time.
It seems like it's just junk data, Miller time. Starliner is having a weird problem with its antenna.
Contact time 4 minutes later.
They were having a weird issue with the antenna on Starliner, and they were getting junk data. So my guess is that the oh, you see the RCS firing. Oh, that's so cool. That's so legit. So I'm guessing that the weird stuff that they were seeing from the NDS may have been part of that. It may have been a little garbled. One of the antennas isn't working as expected, but Starliner has a backup, so it's using the backup. And don't get me wrong, it's like most things carry a backup like that. SpaceX has had to use backup systems on Dragon before. That's actually, believe it or not, it sounds bad, but that's actually something that happens. It does happen. Why do they have junk data? Well, if the antenna's not transmitting correctly, Space Troll, it's gonna tell you that the capsule's doing something that it shouldn't be doing. And the flight controller's job is to verify that the data that they're seeing isn't fake, isn't junk data. So they saw that Starliner was drifting away from the space station, and then they're looking at the cameras and they're like, no, it's still there. So they had to verify junk data, and then more importantly, have to verify why. This isn't just IT, it's troubleshooting, but you have to be able to troubleshoot stuff quick, because stuff can easily go wrong really, really fast. So they did verify that it was junk data. And the NDS, I don't know, maybe somebody just didn't turn it all the way on or something. Turning it on and turning it off, arming and disarming the docking ports seemed to work. They were talking about this retraction ring right here. See where these 3 pedals? There's a little metal ring with those 3 pedals, and that does extend. It's the soft capture mechanism for the NDS, or International Docking System Standard. IDSS is what it's called. But they do call it NDS as well. Those are kind of interchangeable names. Shadow, man, honestly, this flight is really good. You know how I know this flight is really good? Because Starliner's 30 feet away from the space station. If this flight was going bad, NASA would not have it anywhere near it. The fact that that thing is sitting right next to the ISS tells me that everything is going just fine. They're not going to force the issue with their multi-billion-dollar space station that has 7 people on board. You don't want to roll the dice like that. That's not a good idea. The fact that that thing is right there tells me that it is safe enough to be there and that the mission is going very well. Because if it was right here, it wouldn't be there if NASA didn't think it should be there. Let me put it that way. They don't just let anything into that keep-out sphere that the ISS has for no reason. Like, you have to have a damn good reason to be there. And in Starliner's case, the damn good reason to be there is 1, the test mission. And 2, well, actually, no, it's just 1. It's just the test mission. And in the test mission, the objective of the test is to, it's not like a test like observe and report the results, like a scientific test. Testing for spacecraft works more like a final exam for school. It works more like that. You really don't want to learn anything new, but sometimes you do. It happens. Now, you want to make sure you still pass. If you learn something new and you still pass, then you're okay. But you don't really want to learn something new. This tells me that
the docking ring is extending.
Okay, watch this thing right here.
Controller is short for mechanical and power officer.
Now, what NASA has learned hasn't been that big of a deal. The mission on the whole is going very well. Watch the docking ring.
The docking ring is extended, and then that's gonna.
See, it's moving.
Otherwise, keep us in
about a week, Mars.
Position.
Got to make room.
Final approach initiation.
It has to be out of here by the 7th. That's when SpaceX 25 is coming up. Dragon needs that docking port for
Central
food.
Time. Starliner, in the meantime, is at 10 meters away from the forward port of the International Space Station.
Kjell Lindgren is sitting at the RPOD station on the ISS, Rendezvous Proximity Operations and Docking, RPOD for short. He's at the RPOD station, ready to take control of Starliner if he sees something that he doesn't like. Kjell is the commander of the station, if I'm remembering right. Him and Bob Hines, who are 2 astronauts from NASA's Crew 4 crew. They're up there with, so it's Kjell, Bob Hines, Samantha Cristoforetti, and Jessica Watkins. We watched them dock to the station and fly up there the other day. It's actually pretty crazy. And then we watched Crew 3 undock from that exact port like a week and a half ago. It's busy, man. The ISS is busy. This is what I wanted to see. This is what I want to see. This is what we built this thing for. Let's go. It's pretty cool. How do they train for that? Shooker. How do they train for it? NASA does astronaut training at Johnson Space Center. Literally, they have a building out there that has an entire mock-up of the entire ISS. It is a fully working ISS. It's just down on the ground inside of a building. They use that for practice. Is this live? This is live.
MPO reports that the ring has been extended and is ready for capture.
All right. We are ready for capture. The capture window should be in about 20 minutes. So we're looking at the command for FAI, final approach initiation.
Houston, space to ground.
In about 20 minutes.
Houston is go for final approach. Stand by for final approach initiation call.
Oh, there you go, Thomas. Yeah.
Station copies go for final approach and stand by.
Yeah, Enigma. Sometimes, sure. See this white ring on the far left right there? That is the docking adapter that they needed to dock Starliner and Dragon. Oh yeah, they had to bring those up. Believe it or not, ironically, they used a Dragon 1 to bring up the adapter to dock Dragon 2 and Starliner. This little ring right here is called the IDA, the International Docking Adapter.
And you heard
they bring up new parts all the time.
The teams are go for final
new solar
approach.
Panels, new batteries, new docking ports. Oh yeah, they're brought up on Dragon Cygnus capsules. Yeah. They've been constantly upgrading it. It's just not a big physical change, you know? It's not like the space shuttle where you could bring up an entire module. They just bring up little pieces at a time. But it's all little upgrades here and there, sure. It's a good question, actually. Because you'd think when the space shuttle stopped flying, they'd stop adding pieces to it. No. Dragon has a cargo hold behind it. And Starliner doesn't, but Dragon has the trunk. There's a cargo hold behind when Dragon launches, and you could put small ISS parts in there, and that's what they do. The reason for that is that the Canadarm cannot reach into the trunk if the cargo one docks. Oh, to get IROSs out. Yep. They've actually, Enigma, they brought up solar panels too. The International Space Station rollout solar arrays, which
teams here are talking through. There is an opportunity to execute the final approach initiation much earlier than anticipated, to be the 7-minute handover, or a handover in 7 minutes. We can expect the teams, they're talking about it now, to go ahead and execute that maneuver. And they just did. Final approach initiation has been commenced.
All right, they did it early. FAI is coming. Here we go.
Has begun. Perform steps 8 and 9 in 1.102.
Those rollout solar arrays basically work like a roll of toilet paper. You just put it on the mount and then just it pulls it. You pull the thing out. It's pretty crazy. It's smart because you can put it in a small area.
Starliner inside 10 meters.
Here we go.
And on the move, 0.04 meters per second.
That's cool.
It'll take 4 minutes to close this distance of what is now less than 9 meters to the International Space Station's forward port.
About 30 feet out. Green, it's a pretty beautiful sight, isn't it? I just want them to zoom the camera out after it docks so we can see Starliner and Dragon right next to each other. Nothing will make my day better. Two different spacecraft at the ISS from the States. That's pretty freaking cool,
coming
man.
From the
look at this picture
on the ISS.
Oh, it's so good.
Now watching Starliner make its make its final approach. Docking ring extended.
Now kiss. Come on, Starliner. You got to go in there and kiss the damn space station. Oh, well, asking you shall receive, oh no.
From the forward port.
There's the relative navigation system. Look, it's looking for the ISS parts, and it's identified different pieces of the station. Oh, that's so legit, dude. You gotta be kidding me. Starliner's doing that automatically. Starliner is the computer.
Contact a little bit more than 2 minutes.
The computers on Starliner are looking through those cameras and looking for the ISS. In the same way that if somebody was on board the capsule, they'd be looking out the window and making adjustments. The computer does that automatically on this thing. That's so freaking cool, dude. I did not know that Starliner had that. That's really neat.
And at 0.05 meters per second.
The computer's flying the thing. Look at that.
Views between
There's nothing
the
on the space station
and the Starliner.
There's nothing on the space station that Starliner, like an antenna or anything, that Starliner uses to dock. It just looks. It can just look outside. Like, Starliner can look through its cameras and figure out where it is. That is really, really impressive stuff, actually. That's really freaking cool.
Those 3 pedals will inside 4 meters.
Okay, you see the RCS making a little adjustment here. All right, so we're about 12 feet, give or take. Oh my goodness, look at this thing. Hey.
1 minute to contact. Okay. Inside 3 meters.
10 feet.
Quiet in the control room.
Oh, she made a little bit of adjustment.
Starliner continuing to close in.
That's freaking cool, man.
2 meters, Starliner coming
7
2
feet.
meters to the International Space Station.
Actually, about 6.5 now. Come on, baby. You got this. It's been a long time. Let's go.
$1 meter to docking. Less than 20 seconds.
3 feet. 2 feet. About a foot. Stand by for soft capture.
Press to dock.
Ah. Soft capture confirmed right there.
Contact, capture.
Oh. All right, they got to retract the NDS.
Confirmed.
There we go. We got a soft capture confirmed. Perfect.
Now, station showing good soft capture.
They got to retract the NDS part of the system, the soft capture mechanism, and
Boeing Starliner
engage the drive hooks.
Completes its historic first docking to the International Space
Shadow
Station,
Man, it was perfect.
opening a new avenue of access for crews to the orbiting laboratory.
Hell yeah.
That docking time comes at 7:28 p.m.
course,
Central Time. The International Space Station was 271 statute miles over the South Indian Ocean with the Starliner attached to its forward port.
It's a hell of an achievement right there.
Cheers!
First time that capsule's ever gone to the ISS.
After that docking by Boeing Starliner spacecraft, the docking is not complete. It's the docking ring that was extended will have to be retracted to complete the capture. Right now, it's a soft capture.
Novus, it's pretty damn impressive, dude. That's a hell of an achievement right there. Is this the first time there's ever been two dissimilar spacecraft designed by the same country at one station? Russia had TKS and a Soyuz docked at one station, but they both weren't crewed, so if anything, this would be the second time it's happened to someone, which is still pretty damn impressive. Oh, Tedra's hand over.
Connected to the forward port of the International Space Station.
That's a hell of an achievement right there, guys. Oh, look, an onboard. There's an onboard camera.
Flight controllers
Wish they would
working
show us
through
that, but hey, it is what it
their
is.
methodical approach to complete the docking, to complete all the
Sorry,
connections between the Starliner and the International Space Station's forward port.
Except for two Dragons being docked up there, which is not dissimilar. No, I don't think it's ever been done. Yeah. This is the first time. That's why this is such a big deal. Starliner and Dragon are right next to each other. That's really damn impressive. Yeah. Yes, Flykin. Absolutely.
That docking time came at 7:28 p.m. Central Time.
Now I want to see Dragon, Starliner, and Orion at the same time. Yeah, me too, man.
Station Houston Space to Ground 2 for Node 2 hatches.
Oh.
For station.
Tedra's handover is complete.
You are go to open the port and starboard hatches.
See how all the cameras came back?
Copies, we are go to open port and starboard hatches, Node 2.
Oh, they shut the hatches out. Smart. So what NASA did, there's basically a airtight hatch at the entrance to all these modules. They closed the Node 2 Node 2 port and starboard, which are the hatches that go to the Japanese and the European module. The reason why they close them is because you know, if something does go weird during the docking, and maybe you have some type of depressurization event, they can keep it compartmentalized. They basically shut all the locks in different doors. That NASA was telling them that they can open them again because it's docked. It's good to go.
Japanese module and the European module, they'll go ahead and open those that needed to be closed as a flight requirement for the docking phase. So they'll open those up while we wait for the sequence to proceed through hard docking.
Well, yeah, Everest, of course, but it's double crew. Two crew spacecraft from the same country. That's never happened before. That's never been a thing. I mean, don't get me wrong, nobody's aboard Starliner, but this is pretty damn close. It's a pretty damn hard achievement to have.
MPO reports the ring is aligned.
Okay. Starliner is aligned. They'll start retracting the hooks on the soft capture NDS mechanism here. So Starliner will slowly, this part will slowly get closer to this part. It'll reel it in, because that soft capture ring, that little ring that was out in the front, that's just to basically absorb the shock and get everything aligned. When they start retracting the soft capture mechanism, Starliner will start moving very slowly towards the international docking adapter. These little slots that are on this part, see there's little slotted mechanisms right there? Those are the hooks. Those are the hard capture hooks. There's 12 on Starliner and 12 on the IDA. And what's going to happen here is that the hooks, basically when they get near each other, they drive and they hook into each other to safely secure or hard capture the Starliner to the space station. Once you get a confirmed hard capture and all the hooks are good, that means we're done. Sorry, mate. We're done here. No, we're not done. This is number 50. We're not done. You got a problem, take it up with Calitri. Sounds like train car couplers. Kind of, Orion. Yeah, for the most part. So, like...
And you can see it physically. The NASA docking system ring that's on board the Boeing Starliner is retracting.
Yeah.
You can see the spacecraft itself get closer to the International Space Station. In the meantime, the space station's attitude control systems themselves have been configured to allow...
No, they're going to open the hatch tomorrow, Jake.
Hard dock sequence. They have to be in a certain configuration.
Thrusters are disabled for hard mate.
Yep. There
Copy.
you go.
Thrusters disabled for hard mate.
Shut the thrusters off.
And that configuration, of course.
NDS has been working great, so no issues.
Then flight controllers report that the NASA docking system, the ISS, is working as advertised.
Good reports on the thruster configuration. That,
Roger.
That's the attitude control of the International Space Station. That's in a good configuration. And they're reporting that the Boeing Starliner's docking system is performing as expected. You can see the ring retraction, which is close to complete. We'll get confirmation of that soon as we go close.
The ring retraction is slow, so what I'm going to do is I'm going to back it out. See what I'm talking about? I'll back it out. I'll just time warp here. Rewind, fast forward. See what I'm talking about? They're retracting the soft capture NDS. And then how these hooks work is basically a slot. There's a slotted mechanism. And on one side, you have two pins. There's two axles inside of the slot. Right? So the slot looks like this. There's two axles. There's one here and one here. One is a passive, and the other axle has a hook attached to it. So when the hard capture mechanism gets close, there's two hooks and there's two axles, and they'll grab the two hooks. There's some hooks on the ISS on the space station side, and there's some on Starliner side. They basically grab at each other.
Two sets of hooks that will close to complete this docking process. The first set of 6.
I'm not making this up.
Set of 6. So right now they're working on that first set.
Of course you could, N9. Yeah, I absolutely could make an IDSS. Sure.
Once those hooks are connected, there's a couple of umbilicals reaching from Starliner that will
there you go, Shadowman.
connect to the International Space Station. Those will be data and electrical transmission.
Dragon uses a different docking process from Starliner? It's the same mechanism. They just do different things at different times, Journey. But for the most part, it's pretty much the same docking port. Because it's docking to the same docking port at the ISS. They are absolutely the same thing. No fun to be had unless you're making some of this up. Yeah, sure. Yeah, spoilers? Shh, it's not spoilers. I'm just ahead of the curve. Pharaoh. I know, dude, what do you think? I just some guy
all
on...
6 hooks on
first, I played Kerbal, now I'm an expert? No, dude, I spend copious amounts of time reading about this. Probably gas, yeah.
Next up,
hasn't happened yet, Talon. I agree with you.
Second set of hooks.
They could, C-22, in theory, yeah. It's an androgynous attachment system. So, yeah, you could... two IDSSs can dock to each other, absolutely. So what do I think about it? Let him keep thinking that, Grumpy. In this world, somebody has to be wrong and somebody has to be right. And guess what? When it comes to spaceflight, I ain't wrong. How would we know what's right and what's wrong if there wasn't people that were wrong about things out there? That's all I'm saying, man. Missed it. Did it dock? Yeah, Kim. It's pretty smooth, actually. Yep. Yeah, here, take a look. Can I just go back and look
inside 4 meters?
Hey, how you doing? You see, there's the hook and then the axle, like I'm talking about right there. Oh, that is really nice eye candy right there, if I do say so myself. Whew.
1 minute
nice.
to contact.
That's nice. It
inside
is
3
crisp,
meters.
man. Yeah, I think this vessel is called Sea Anchor. I'm just kidding. That's the hoist point for. All right. Anyway, almost KSP like.
Starliner continuing to close in.
Yeah, here, let's get
And this is the first time that we have both commercial crew partners dock to the International Space Station at the same time. So a really cool sight to have both Crew Dragon.
Yeah!
So teams are continuing to monitor as those hooks drive to firmly secure Starliner to the space station. And it takes about 10 minutes for that hard mate to be secured. Now the solar arrays on the International Space Station side will be maneuvered back to their previous configuration after having been feathered, which means they are oriented and protecting them from any inadvertent impacts from the vehicle, like the thruster firings that we saw during that hold and as it approached the vehicle. Later on, they will pressurize the vestibule, which is the space between the station hatch, which was exposed to space previously, and Starliner's hatch.
How many years for this?
Now that Starliner
12?
has arrived, the crew has to wait until tomorrow for hatch opening, but you can watch live starting at 11:30 a.m. Eastern Time.
Gonna be there for that.
It's moving pretty smoothly here in Mission Control Houston as those hooks continue to drive, but to carry us through the rest of that process and to keep us up to date with the latest on Starliner, sending it back to you and Gary over there in the Starliner flight control room. Thanks for joining us here in Mission Control Houston, and that'll wrap it up for me tonight.
I know, public, isn't that weird? Hey, wait, fellas, hold up. Look. Trampoline, broomstick. Am I right? Am I right or am I right? All right.
There are 6 hooks that are keeping the Starliner secured to the International Space Station right now to complete a hard capture.
It did get there on an RD-180, didn't it?
Second, what's called a gang of hooks.
So
that's another 6.
Funnier, dude.
There's a period in between the closing of each hook's for an assessment before they go ahead and continue to drive those hooks for secure docking to the International Space Station. We're just standing by for that. But a recap, we did have 7:28 was the
hope we see it. Here are the bits for the joke.
Soft capture time, where the Starliner spacecraft made contact with the International Space Station. At the time, the station and Starliner were traveling 271 statute miles over the South Atlantic or South Indian Ocean, just south off the coast
Yeah, that must suck
of
to
Australia.
suck, though, huh? Oh, that's such a good... dude, this makes me so happy. That's so funny. The joke is funny. No, I didn't mean to say that. Sorry. The joke was funny, but that, dude... that is a really nice sight. I can't even speak straight. I'm so happy. You think both capsules are in love? Hell yeah. So Starliner's going to be up there for a week or so. It'll vacate this port after they test all the... station power systems and whatnot, and they, the crew is going to offload cargo onto it, believe it or not. This is working like basically a resupply mission. There's some cargo on board. Starliner's going to take down some O2 tanks for the ISS, believe it or not, so they can refill them and send them back up. And then in a week, this thing should bolt out. The Crew 4 Dragon that's up there will undock. It'll redock to this port, and then a Cargo Dragon is actually scheduled to come up and dock to the top port that's up there. in about 2 weeks, 2.5 weeks, June 7th, SpaceX 25 is going to come up there. Now, Thomas told me this. You told me this a second ago, and I didn't know this. I didn't realize it. The Cargo Dragon is going to be carrying new modules for the ISS, new parts for the ISS. So they need to put it up on the docking port that's up there so they can get at it with the Canadarm, because the cargo on that resupply Dragon is going to be in the trunk. So if it's docked with the trunk facing that way, they can't reach the arm up and around. It's easier to kind of reach in the pot and take out the parts that way. Is CFT slated to fly on Vulcan? No Starliners are slated to fly on Vulcan right now. ULA already has the contract for all 7 remaining missions for Starliner. The CFT, PCM-1, PCM-2, PCM-3, PCM-4, PCM-5, and PCM-6. All the atlases for all the Starliner crew missions are secured. Tori Bruno already bought all of them. There are no contracts right now for Starliner to fly on Vulcan, but I wouldn't rule that out either. It definitely could. Give it a few more weeks. Vulcan, what I've been telling people is that, we might be connecting dots that aren't there. We might not be, but it would probably make sense that Starliner will end up flying on Vulcan. Nice. Vulcan, that's cool. The sooner the better. Yeah, it's... I don't mind using RD-180s. I don't mind using RD-180s. They're our engine. Also, Cam, here. Want to see something funny? Look at this. So these pictures just kind of were floating around on the internet a little while the other day. Here. Look at this. Look at this picture. You'll like this. All right. Yeah, those pictures started. Those pictures started floating around on the internet. That's an RD-180 that was made here. Just putting it out there. That's it's an RD-180 that we made. Aerojet Rocketdyne made that sucker. Just saying, oxygen-rich Carolock stage combustion cycle. It's pretty good. It's pretty good. Pretty good. All right. Yeah, Thomas, that's right. Oh, hey, it's an AR-1. Someone please give that engine a job.
Discovery, go at throttle.
Hey, Casper, 16-month resub. So the ISS needs more docking ports, I guess? Don't worry. When Dream Chaser comes up to that thing, you'll have the opportunity to get more docking ports. If I'm thinking about it right, Axiom. That's not confirmed, but I'm pretty good at figuring this stuff out. Luiso China style. You're not wrong. All right, guys. Well, that's going to do it. I'm waiting on hook capture confirmation here, but how is Cortana? Where is she, Chief? Where's Cortana? Oh. Yeah, I'm sorry. What? Sorry. Oh. I don't see your last squish. I'm looking for it. I don't see it. Type it again, buddy. Chief didn't make it. Let's do something productive. Stop talking about space. Round, I will kick you square in the junk if you say that in here again. Better watch yourself, boy.
Station Houston, Space to Ground 2 for Starliner. We're currently in the process of driving the second gang of hooks.
All right. Once they get the second hooks driven in, guys,
station copies. Good news.
That's where we're gonna
second set of hooks driving
off
now.
Finally solves everything.
That connection. 6 have already closed.
What is AR1 going to be used for if not Vulcan? Doesn't have a job right now, Squish. But they wouldn't be making it if they didn't have a job, so it's probably a contract that we don't know about yet. Meeps! What up, playa? Oh, what's that, Vulcan? Oh, that's a nice picture. Nah, Fishy, Round's just kidding. He's one of us, don't worry. Hey, Super, there he is. Long time no see, man.
Reports all of the second gang of
it did bring up some
hooks
cargo caging. Yep. Upgraded Antares, maybe.
All 12.
It could do that, couldn't it?
Meaning that Starliner is fully connected to the International Space Station docking board. The umbilicals will be extended momentarily to connect the video and electrical networks, the data and electrical networks between Starliner and the International Space Station.
That's crazy. Squishton, they should just use AR1 on Vulcan until Blue can provide their engines. Wait, Squish, you know that Blue, like Amazon gave Blue Origin, ULA, and Ariane Space like a $10 billion contract for like 50 launches between New Glenn, Ariane 6, and Vulcan. 38 Vulcan launches. Believe me, they have the engines. Yeah. It's the largest block buy of rockets in history. Yeah. Oh, I wouldn't worry about Vulcan not having those BE-4s on time. Don't you worry.
Hard docking complete.
There we go. She's docked. 2 in the dock, ready to go. We be fast and they be slow.
Starliner.
Wow.
To dock mode.
Congratulations, guys. That's awesome.
Another first.
Hell yeah.
That's applause you hear.
Houston, Space to Ground
Not hint.
2
It's the AR1 engine. Okay.
Go for station.
Hard mate is complete. ISS thrusters are enabled, and we can welcome Starliner to ISS.
Oh, ring the bell.
That's great news. Thank you to Rob. Thank you, Rob. Thank you to the entire ops team for some great work tonight. As the joint Boeing and NASA team, the crew of Expedition 67 would like to offer our congratulations on this momentous occasion. Today marks a great milestone towards providing additional commercial access to low Earth orbit, sustaining the ISS, and enabling NASA's goal of returning humans to the Moon and eventually to Mars. Great accomplishments in human spaceflight are long remembered by history. Today will be no different. So to Starliner, its commander, Rosie the Rocketeer, and all the men and women who poured their hearts and souls into this vehicle and this mission, welcome to the International Space Station.
Hell yeah! That's what I want to hear, baby. All right!
Great words, Farmer. Thank you so much for all your great work today.
Sorry for clapping in the mic, guys. My bad. I'm pretty hyped. That's really cool.
And Station Starliner Control Center here. Thank you for the great words. We are happy to be there and looking forward to a great mission.
And likewise, and Starliner is looking beautiful on the front of station.
Today is a good day.
We love it too.
Yeah, see, mission controllers need to keep their cool. And the astronauts are like, hey, look at how cool this is. And freaking flight director's like, yeah, it's great.
It's Station Houston.
You gotta keep your cool.
One more
yeah, it's good
for you when you're ready to copy.
Yeah, hey, this stuff takes time, but the payout is money, dude. Look at that thing. Look at that thing. Look at that thing, man. That's great.
Starboard hatches are open. You can perform step 2 of 1.301. That's the uncrewed CSD 100 post-docking leak checks and ingress, and then hold for step 3.
Okay, copy that. The hatches are open, and we're go for step 2 of 1.301.
The CBM...
Good read.
The CBM PMA hatch, that's what the hatch they're talking about opening, and then they said they were going to go into the hatch procedures. Hold on a second here. Yeah, that's right, Vulcan. It's from the town over. Next to me, dude. Yeah, there's an elementary school in the town just south of me that's named after her. Yeah, Sonny Williams Elementary in Needham, man. It's pretty freaking cool. Yeah, Franco, right? Oh, it's such a good day. Good job, guys. Good freaking job. You do be docked, though.
Congratulatory words all around. You see some handshakes here in the Starliner mission control room. Flight Director Ed Van Cise. After some of the communications you heard between Bob Hines aboard the International Space Station, the International Space Station Capcom Rob Hayhurst, as well as Neil Legata that you see here as the Starliner Capcom. You heard some of the congratulatory words up to space. Van Cise addressing the teams here in the Starliner mission control room, congratulating them for the hard work that it's taken to get to this moment. You've seen handshakes, you've heard applause in this room. A very momentous occasion here in Mission Control, Houston.
Oh, I love him, Kuro. I don't know what you're talking about. It's funny because the guys that are talking, the guys that you hear talking, that's Gary right there. There they are. These two are talking.
And congratulations among all the Boeing team as well, Boeing and NASA working together on this whole mission, on this whole program, of course, to get Starliner in this position, launched up into orbit, and now connected to the International Space Station.
Good pictures, eh? That's a really good picture.
Go
ahead, Sean.
I understand we are go in 2.1 to uncap the node to forward MFEF.
Joe, you are go.
I wonder, are they just going to say screw it and open the hatch? It makes me happy, Franco, that they're using a shuttle flight control room. That makes me so happy. Dude. Oh, that makes me really happy. It's really nice seeing those rooms get used again. You're right. Starliner's flight control room is using a shuttle's flight control room in Houston, which... I like that. That really makes me happy. I don't know, Zay. We'll see. I thought they said that they were going to leave Starliner's hatch opening until tomorrow. Was it something else before the shuttle? Maybe an Apollo room, Angry. I don't remember. It depends on which room they're using. There's a couple of flight control rooms. The shuttle control rooms were being used to store stuff. Square in the junk, man. Square, like this is you, this is me, and my foot ain't gonna go in here. It's gonna be my shin. You know, you got to make sure that you get your foot behind, right? So your shin just absolutely obliterates everything up in there. Sorry, man. Got to make sure your shin gets up in there. Sorry. It's going to obliterate everything up in there. And you get kicked in the butt at the same time. Don't go around testing this theory, please. Nobody do that. Violence is bad. Don't do that. Don't do that. Instructions unclear. Kicked sibling in crotch. Wait, what? No. I'm going to need an image of this, please, for scientific purposes. Yes? I don't know. No, that means somebody needs to test it, and I'm the only one with the required equipment to test. Yeah, Taz, we don't need it. But it's for science. That's what I like to see. Good mission success right there. Flight controllers have the best handshakes. Watch the handshakes. They're just good handshakes. Instructions unclear. How do I join the racing? Friday night racing? You got to go on the Discord and got to download a couple of mods. There's a walkthrough on how to do it in the Assetto category on the Discord, man. And the proof is in the pudding. Look at some of those handshakes. Damn, that's a good handshake.
Busy Starliner
so
mission
good.
Control here in Houston. Leadership from Boeing and NASA have entered the room to shake hands with all the flight control teams who have put forward the hard work to make this moment possible. Starliner docked with the International Space Station at 7:28 p.m. Central Time. Lots of smiles, congratulations, and handshakes. It's certainly a busy room. For our coverage, we are nearing the end of our coverage now that
look at that handshake. See that handshake? Damn, that's a good handshake. I love good handshakes. It makes me happy.
However, we are going to follow up our coverage with a teleconference. If you'd like to monitor the teleconference, we're planning to start that at 8:30 p.m. Central Time, 9:30 p.m. Eastern.
It is.
You can follow that on nasa.gov/live, and if you are media and
such good handshakes, man.
Please reach out to the media contacts identified for the NASA teams.
Exclamation point Discord,
the right contact information. So from the NASA side, Steve, that's it for me. This was a very momentous occasion.
That's Steve Stitch, commercial crew. He's the commercial crew program lead. That guy runs the whole show. That is the gentleman from Boeing. I forget his name. He was in the presser yesterday. He's the guy that runs the Starliner program. Who else is in there? I'm not sure I know the rest of these folks.
To reach this milestone,
that's
you
Mr.
everyone
Boeing.
Who's joined us this evening.
That's Barry Wilmore right there. He's a NASA astronaut. He's gonna. He might be one of the first guys that flies Starliner.
It's really something that a lot of
people
are not going to forget. This is
that might be
Jasmine
teamwork, but I'm not sure.
Of course, that's really what we're seeing today. You mentioned Gary hatch open tomorrow, and so everybody will be back in for that. And in the meantime, we are going to say thank you to everyone for
Sagittarian.
For listening in today and for watching our coverage.
Thank you guys. This is fantastic.
Go Starliner, go ISS, and we will see you all tomorrow.
Good. Damn good handshakes, man. Oh, that's the best part. Let's get a smokes and some cognac, baby. Let's go. Gotta celebrate. Sorry. Press conference coverage. I'm gonna be racing Astro, but we can rerun the press conference tomorrow. Fellas, I think they said at 11:30 tomorrow they're going to do a hatch opening ceremony. I may or may not be around for that. Still gotta make sure all my T's are crossed and all my lowercase J's are dotted with the house stuff. Like, I just want to make sure. We did sign PNS today, but there's still a lot of stuff to do. So. Cognac and cigars. I'm in roundabout when we doing it. So, that's going to do it for the coverage. I've got a bamboo cocktail. I have dihydrogen monoxide. Oh, man. That's real potent stuff. That's right, Round. Yeah. Dude, I'll show you guys when... not when. We still got to close. I still need the keys. I'll show you. Round, I'll show you. This house has a damn high bay in it, dude. The garage is 1,000 square feet. 15-foot ceilings, dude. We found a freaking winner, man. So, yeah. EJSA HQ. Trust me. Yeah. We haven't closed yet, but we're getting there. But anyway, guys, I hope you enjoyed the Starliner coverage. It's fun, wasn't it? That's really freaking cool. I know it doesn't look like much, but there's thousands of freaking people that work on these projects. And you know what? It's to the point where I know a lot of them too. These guys work so freaking hard. This is not easy stuff to do. They bust their tail, and it's really happy. I'm really happy to see Starliner pull through like that. That dude feels really good. Feels really good. No problem, Schnoid. I'm glad you liked it. Thanks. That was historic. Jim was awesome. So good. I hope you guys enjoyed it. It's a good time, isn't it? But I'm not stopping, actually. we're going to do my Friday Night Racing League, baby. We got Silverstone today. Silverstone with LMP cars, so that should be fun. If you want to stick around, I'd really appreciate it. If not, that's cool. Racing and space have a little bit of crossover, but not much. But check this out later. Sure, dream job. Hope to work on one of these missions for one day. For sure, Astro. I hear that. Oh yeah, that thing. That's weird. Jim, huh? Yeah. Are you excited for F1? Of course, Taz. Yeah. Of course. Mick got P9 and FP2. Of course I'm happy, right? Wait, Taz, you like F1? Really? Why'd you never tell me this? Oh, really? All right. I thought you knew. You probably told me at some point, but that's awesome. Hell yeah. Formula One's kick butt. I like that. Yeah, no, I've been watching. My dad introduced me to Formula One in like '96. I've been watching Formula One for a long time. It's like 25 years. Oh, no way. Oh, that's right, Taz. You do play F1. I think you play the F1 games. I'm stupid. Don't listen to me. I'm an idiot. Not just like I was born in '96. Estoy viejo. ¿Sí o no? But yeah, Taz, that's cool. Yeah, no, bunch of big F1 fans. We're gonna play Assetto here, and we're gonna race on Silverstone. We might have Formula 3s lined up. I have to ask. I got into it about 10 years ago, and I haven't looked back. You ever go to the race in Montreal, Taz? No, el dad es mental. Shh, silencio. Have you ever been to an F1 car Indy race in person? Never been to Indy. Been to multiple Formula One races. Been to Montreal a bunch of times, Christian, and Austin. Yeah. Oh yeah. Now I'll eventually go to Miami. We'll eventually go down there. Excuse me, one Bicarus. We'll play it sometime soon, 95. This week's been a little... it's a little nuts, dude. It's been a little insane. You'll be at the 500? Oh, that's awesome, Mongoose. Yeah, we got Indy this week, too. Oh, it's such a good dude. Third week of May is always the best. It's always the best. Because you either get Monaco, Indy 500, and then, what's NASCAR doing? NASCAR's doing the Coca-Cola 600, I think. It's great. Yeah, it's just fantastic. Just a great weekend for racing, man. Charlotte 600 in the All-Star race. I still don't understand how that works, Squish, but I will watch. Yeah, hey, fellas, I know I'm an anomaly. I like all racing. I'll watch Indy, I'll watch Formula One, I'll watch NASCAR. I don't care. I like seeing things go fast. And you know what goes the fastest? Spacecraft goes the fastest. I got the need for speed. Yeah, I know, Tape. I know you get Monaco too, right? That's next week, though. That's next week. If it has an engine, I'll watch it. I'm with you. All right, guys. So I'm going to take a quick break, and we will jump into some racing here. I hope you enjoyed the Starliner coverage. When the thing comes back down next week, we'll be here. So if you like me putting my crappy commentary interlaced with movie quotes over NASA's commentary, I got you. I'm the guy. You talk to the guy? Holy pick. Okay. See you soon, Taz. All right. Ooh. This is Sergei Korsakov up on the ISS. Look at this picture. Oh, that makes me feel feelings. Oh. Huh?